Welcome to this masterclass tutorial on KeenTools GeoTracker. I will be going over many features GeoTracker includes, so let's get started. In this section, we're going to go over the installation process. So when you go to the KeenTools website, you're going to look for your download, and specifically you want to look for the Houdini version number and the OS. So there are currently two versions supported, which is Houdini 21 and 20.5. And also for the OS, Windows, Mac, and Linux are all supported. So you want to download that zip file. Once you do, you can, in this case, I'm on Windows, you can right click and extract all and get inside the zip file. You can also double click in here and you will see the KeenTools folder and you will see a JSON file, keentools.json. Now the folder is the plugin itself, and this JSON file is actually holding information that Houdini is going to read to find the plugin. So it's basically a folder path. If I was to open that JSON file, I would be presented with this little bit of code here. So this H path is a little variable that basically Houdini will read and read across here this file path that's assigned to this variable. So what's showing up here is a little bit of shorthand here. This is just a simple variable here, Houdini _ user preference directory, that is automatically saved internally. That gives us the direct path to our preference. Now for the preferences on Windows, they're going to be in the username documents Houdini version number. For Mac, it's going to be in the library preferences Houdini and then the version number. And on Linux, it's going to be the username and then the Houdini version number. So essentially, this little variable is holding that path as a general kind of ease of use variable. After that, the packages folder, and then the KeenTools folder. The KeenTools being this plugin folder here. So what we need is this package folder. So when we go to our user directory, so if I go to my documents and then I can look at my version number, Houdini 21. If you have more than one install, you can see 20.5 and 20 and so forth. You want to grab the correct one. So 21 is where I want to go. You want to look for the packages folder. Now this may or may not exist. If you've not installed plugins prior to this, this folder may not exist, which means you'll need to create it. So on Windows here, you can just right click and go down to new, which should be in the list here. Let's go to this one. There we go. New, and then you go to folder and create a new folder. And then you want to name it packages. And this is verbatim. It has to be lowercase, and it does have an S on the end. So packages, that full word. You want to name it that because this is specifically what Houdini is looking for. So once you have the folder, you can go inside there, and then you'll install by just copying, pasting both files from the zip file over into this folder. So you'll end up with the KeenTools folder and the JSON file. So that's all you have to do. Once you've installed that, you can start up Houdini. If you haven't Houdini open already, you'll need to restart it for this to take effect. But that's all you need to do to install the plugin. So what is GeoTracker? What I have here is a couple of examples that I've worked on while being on the alpha. The top portion here of this cat and of this alleyway are the effects, and the lower two are the raw footage. And on this second clip section here, same thing, the effects is in the top left, and then obviously the effects are on the right over here. I'm gonna play that while I explain it. So GeoTracker is a geometry-based animation tool that specifically animates the position and rotation of a 3D geometry object that is tracked relative to a camera based on an image sequence. So like in this case, I'm using images sequences for all of this here, and I've put in these effects based on the motion from that footage. Now, what this means is that we can take recorded footage as an image sequence, in this case, and track it to extract motion from it, and then apply that motion to our 3D geometry. This is commonly used to create effects in 3D world space that can follow or be aligned, like in this cat's setup here, and this head and the scarf here. to be aligned to some portion of the 2D footage. You know, the footage is recorded pixels. You know, this was filmed on set in the real world, but when we have the footage, we're dealing with just pixels. It's flat, it's 2D space. So the goal is that this motion can help us integrate the effects more easily into our footage after the fact and have it appear believably that it too was there on set at the same time the footage was recorded. So the GeoTracker process requires a few key things. One, it requires an image sequence of some footage that has an object you would like to track within it. Second, GeoTracker requires a 3D geometry object of a similar shape as that footage object that you are trying to track. And finally, it needs a 3D camera object to be able to translate from the 2D motion to the 3D motion that we extract from that specific view. Traditionally, this comes from a dedicated tracking department or as an individual effects artist. It's something that you would provide normally. So GeoTracker, thankfully, does, however, have a camera feature to help us with that step. And I will be going over all of that. The idea is that we are filming from the perspective of the original recorded footage and trying to match that same perspective with our 3D effects. So in this section, we're going to talk about where GeoTracker resides. How can we access GeoTracker? There are two primary workflows. One is the OBJ object level, and the other is in Solaris. For the OBJ level, we can see that we are at the object level right here. We can type in geometry, and this will give us access to the geometry. If I double click and go inside, will give us the geometry context. This is also known as SOPs, surface operators. So in here, we can access the GeoTracker. And from the GeoTracker, we can also access our geometry, whether that's imported or built from scratch within this context in here. Back on the OBJ level, we can even create a camera here. Now, the alternative to this is over in the stage context. This is going to be Solaris. And when this switches over, the viewport will update as well because the stage has a unique viewport that allows us to access Karma, and you'll see these drop downs in the perspective menu here. So for stage, this is a USD context. So this is a different workflow than Houdini's native workflows, and that's because of the USD format. So in here, we can still create a camera, just like we normally did on the OBJ level. But for the geometry context, we have to use what's called a SOP create. Now, there are a few other SOP nodes in here that we can import SOPs from other areas, and we can also modify SOPs. And that's going to be when you have pre-existing stuff. So the SOP create, if we go inside of here by double clicking, we'll have a different layout here of these inputs, but we do have the geometry context, as we can see right here. We can then build and put down a GeoTracker. So our geometry can be built here. You can independently have a separate SOP create and put your geometry in here to keep things organized. So you can have your asset built in one SOP create, and then you would just object merge it into this location. So this gives you a little bit of flexibility to minimize how everything is consolidated. The same would hold true on the OBJ level. If I go back up once again, I'll get rid of this and go back to the OBJ level. We can also have a separate geometry here, and this could be our asset that we build, and then where we're going to track, we could put an object merge here to bring in that asset and then use that for tracking. An alternative access as well, say we were to build our geometry instead of merging it in, we built our geometry here. We can also access Solaris from here with a LOP network. Now, stage is shorthand that's used context-wise for the Solaris name, and LOPS is basically another shorthand. So like SOPs for geometry, LOPS is kind of the underlying term for the stage context, and this is standing for lighting operators. So when you put down a LOP network, you can double click to go inside there and you have access to the stage. We'll see Solaris right here. When going inside, you will notice that there are no existing files in here that we had over in this stage, the camera and the SOP create. And that's because it's a unique instance. So this is independent. Each of these areas are independent of each other. So this is allowing us to create a stage within this context right here, of which we could then do a camera as well as a SOP create and proceed with that same workflow here if need be. This is just more personal preference as far as workflows go to have something at this level. In this section, we're going to go over the tracking process. I will note too that as I work, you will see any keystrokes I make in the bottom left corner here. So as I double click and so forth, if I hit any hotkeys, you'll see those in that corner. Let's begin by saving our project. So we can go up to File, Save As, and this is always a very important process to do. This step is very vital, and you don't want to forget this. I'm just going to call this boxes. By default, we'll see this $hip up here, and we just automatically went to a random folder here. I want to say this is my home folder on my computer, and that's because nothing's been defined. When we save our project file, I'm going to put it inside this Foxes folder that I have, and hit accept. When we save that, what's most important about this is, one, that we have the project file saved, but second, we have global variables. So if I go down to Edit, Aliases, and Variables, and I'll bring this over here, this second tab, Variables, we'll see hip file, and job. These are very common expressions that we will see throughout Houdini, hip especially. You will see these global variables, this is what they're referred to as, designated as $ and then this name. So $hip file, $job, and basically they're placeholders. They have some kind of assignment to them. In this case, it's a file path. Now these are automatically set, these hip and hip file, based on where you save the project file. So as you create file paths later on, this is a convenience of not having to type all of this out. If you wanted to use a job version, this doesn't auto set, but you can type a file path in here to change that. And then there's also helpfuls for pi and a few other aspects in here. So those global variables are important, and you get that set up when you actually save the project file. So let's begin here in the object level. We're going to create a geometry object, and we're just going to call this boxes tracked. And we just want to give it some kind of naming convention that makes sense. So we can jump inside of this node by typing the hotkey I, and you can use U to jump back up. So I and U, as long as you have the node selected. We can create a file SOP, and you'll hear that term SOP, surface operators, so I'll be using that for geometry. For the file, we're going to load up our 3D geometry file. So in my case, I have one pre-made. If you are making your geometry, you can, like I said before, have that in another geometry, or you can build it in the same space you're going to be tracking. But you would want to, at the very least, have a null at the end of your node stream that kind of names and designates what that file is and what the asset is, just for easy reference. That way you can then connect that straight up to the GeoTracker. So the file here under geometry file, we're going to click the little icon on the right here, and we're going to navigate to our geometry folder. And in this case, I'm going to use the foxleft.obj. So this is an object OBJ file format. And there are, if you have an alembic, you would want to use the alembic SOP. There is FBX as well, but mostly this is for character animation. There is an object level FBX import that can be done through the file. So you can merge through the import file, Filmbox FBX, as well as an alembic scene. So you can bring in files that way as well. This is specific for alembic, but you do want to make sure that it's a static object. You don't want to have animated geometry or deforming geometry for the track geometry. So this is a static object. I'm going to zoom it out here just so we can see what that looks like. It's just a fox mask head. We will see the $hip in the file name here. And if I middle click the parameter, it'll evaluate that expression and show me the actual path that it's going to. So we can see that it's going to that freelance KeenTools tutorial project Fox's Geo folder, where that's located. And Geo is a separate folder here and the object right there. So that's why the $hip is important, because if you don't save your project file, your files will go somewhere else on your computer where the default folder is, and you do not want that. So we have our file. Let's create a GeoTracker. And I can type in GeoTrack or GT, do acronyms will work, and I can select it that way and bring it down. Or alternatively, you can hit Tab and go to the KeenTools folder and find the GeoTracker right there as well. And then we can just connect that up. It'll take a second here for it to kind of initialize, and we can display the display flag on the GeoTracker. So we have our 3D geometry. Now we need our image sequence. So that's two of the three things. We did not create a camera, and that's because we're going to use another feature for realistic scenarios where you may not have a camera to work with from the start. So the first parameter up here is our image sequence. Same thing, we can click this little file icon right here, and this can go to where our footage is located. I have a Fox's $F3. I'll explain that in a second. But it's a 200 frame sequence, essentially. Now, if you see a bunch of individual files, like this case, it's a JPEG sequence, that would be because this shows sequences as one entry is not checked, or the numbering is not correct on your sequence. So you can click that to make it all show as one file. Select that, hit accept. We'll see the same thing. It uses that shorthand $hip. And then there's the $F3. $F, for those who don't know, is the current frame. So frame 1 in this case, all the way through the rest of your timeline. The 3 on that is just for padding. So how many zeros should it pad for the number? So this should be 3 digits, and whichever digits are empty will be a 0. So if I middle click again to evaluate this, we can see the full path, and we can see the Fox's .001. And if I was to step a frame forward, we can see all of the other frames. Now, we know that this is a 200 frame. I'll click the file again. 200 frame sequence. So we want to make sure, first and foremost, our timeline matches that. Right now, the default is 240. And that's how the default Houdini file opens up with. The bottom left corner, it's very small. This icon down here is the global animation options. Alt-Shift-G is the hotkey for it. But if I click this, we can get this little panel here where we can set our frames per second, as well as our start and end frame. So I could type 200 here and make sure my frame rate is correct, and I could hit apply, and this would end up setting my timeline and frame rate. But instead of this, I'll put this back here. The frame rate, we will make sure that it is 24 because that is our frame rate. Close this. There's a handy little feature under the image sequence here. We have the file selection. This is file reload, so you can reload the sequence if you made changes. And then the third one here actually sets the playback range. If I was to click this, it's automatically going to set our timeline to that 200. So we have our 1 to 200 for the playback. Now, unfortunately, with image sequences, there's no embedded information to define the frame rate. So you will have to manually make sure that you set the frame rate under the global animation options. So if you have 30 frames per second, 60, and so forth, you want to try to keep it an integer frame for the best 3D experience. Okay, so we have the footage loaded up, but we're not actually seeing anything. And that's because we need to make sure our geometry tracker is selected. And like with any node in Houdini that has any interactive mode to it, we have to enter it. So we have to hover our cursor over the viewport and click enter, and we'll now see our footage. I'll go ahead and hit the up arrow key to let it play through. And just to make sure it plays in real time, I'm going to click the little clock down here for real-time playback in the bottom left corner, and just let that play through. Now, one thing to note about image sequences and the footage that you use for GeoTracker, it is assuming, and it kind of requires, that the footage is undistorted. Now, what does that mean? That means that lenses that are used to film, like wide-angle lenses, fisheye lenses and such, have a tendency to distort the footage. It can do what's called barrel distortion, and there's an inverse of that called pincushion. Now, let me hide Houdini for a second here, and I have an illustration to kind of show this. And I'm going to annotate on top of this. So the one on the left here, this image, has this curvature to it. All of the straight lines are arcing in some way around the edges, and it's most extreme nearest the edges. This diminishes quite a bit when you hit closer to the center of the lens. So these lines in here tend to be a little more straight. They're not as obvious. So this is called barrel distortion. This can really affect a track because it's destroying the information. The straight lines are no longer straight as we get to the edges, and that curvature will destroy the track, and it would also destroy your composite of trying to put a 3D element that's traditionally square pixels into something that's distorted like this. The opposite being pincushion, and we can see how the bowing on the outer sides are going inward versus outward. So we can see this one kind of going in, and again, towards that center, it's starting to get a little more straight. So that pincushion is basically pulling everything towards the center. And I'll draw a few more arrows here on each of these corners. So this is pincushion, and that's barrel distortion. So that is one thing you want to pay attention to, is distortion that's happening in your footage. You want to run some kind of an undistort process, be that through a third-party tracking software. I know SynthEyes has something along those lines where you can undistort. I know that most compositors like Nuke and After Effects have lens distortion plugins that you can both distort and undistort. The more accurate you are with that, the better. But the goal is you want to have everything be straight in the lines to where you have no distortion happening in there. So that's one important note about the footage. You can still track distorted footage to some extent, but it definitely will severely impact the quality of the track. The other is going to be occlusions. So I can hide this for a second and bring this over to kind of illustrate. So if I was tracking this face right here, and as this person moves, not only do we have barrel distortion occurring on this, but the face is fairly centered. So this could be something that could be trackable because the distortion is not going to be nearly as bad. But obscurification is going to be stuff that goes in front of that surface that I want to track. And that includes lens flares. So we can see like this lighting right here, as the person goes right in front of it, we have all of this detail that immediately gets destroyed in the pixels. This is baked in. So we do want to be careful with that, and obviously with any physical objects. His hand doesn't go completely over his face, but there are times where you have objects that will block, say like this collar right here. If you wanted to track the chin, that's blocking that information. So you want to be careful about stuff like that. It's definitely trackable in other ways. It just is involving a lot more work. So you definitely want to be careful with that. Another note is compression. So you can't see it too much in this one here, but if you had a highly compressed image, you are also destroying the tracking information. So if this was not an even gradient here, and say it was more jagged, where this is a darker blue, and then say this section was lighter blue, and that can happen from compression. You start seeing these compression blocks, patterns throughout your footage. That stuff can also interfere. It's just as bad as obscuring the character or the object that you're trying to track inside of the tracker itself. So you do want to be careful with low quality footage. So now that we have our footage imported and we can see it, we can look at this second parameter here called analysis file. We can see a little checkbox here, so we can turn this on or off. It's on by default, and I highly recommend keeping it on. What this analysis file is for is a kind of pre-process. There's a pre-calculation of the footage that takes place that runs an optical flow process. And what this is going to do is help assist the actual tracking itself. Not only does it speed it up, but it helps inform the motion that's going to occur. We'll see that this also has the $hip. That's going to then go into the same folder as our project, as well as where our footage is at the moment. It will create a subfolder called KT_analysis. Again, you can customize this if you want. This is just the default setting of it. It's going to use the hip name, dot, and then it's going to use $OS. These are also the global variables that I was talking about earlier. $OS I didn't mention, but what this is referring to is the name of your node. So GeoTracker 1 is the name that will be placed right here. And then .precalc is the name of the actual format. So if I middle click the parameter here, we can see the full path. We can see it says Foxes, which is the name of our project, .geotracker1. So this process, we can select if there is a pre-made pre-calc, which I do have one, but I'm not going to use that. I'm going to click over here, the Analyze. And what that's going to do is allow you to choose your start and end frame. I'm just going to do the full range because that's what we need. And click OK. And what that'll do is analyze each frame. Now this is 1920 by 1080 footage, and it's only 200 frames long. So this is going to move fairly quick. As a point of reference, I have done 4K footage, 700 frames long, and it took roughly about 6.5 to 7 minutes, which is still not bad at all. And that little hit is so much worth the extra boost that we would get from the track speed. So the in-between here, this little eye icon, if I click that, it's basically just some information for where that path is, what the frame range is, and what the frame size of the footage is. Okay, so now that the analysis file is complete, click OK on this, and we can take a look at this camera parameter. So that third key element, camera, we have our footage, we have our 3D geometry, now we need a camera. By default, it's set to virtual. There is a second option here for object/lop. Now, the virtual camera is exactly that. It's virtual. It's an internal camera that the plugin uses, of which its controls can be found right here in the virtual camera settings. In here, we can see all of these options from lens to estimate focal length, the focal length, aperture, translate, rotate, and near and far clipping. For our tests that we're doing right now, we're going to basically leave these all at default. I do want to note just really quickly that aperture, if there are any photography users out there, this is not relating to the f-stop. This is actually the sensor width. So this is 36 millimeter for the sensor width, and focal length is also in millimeters, so a 50 millimeter lens. The alternative option on that is object/lop. This is going to affect our visual at the moment because we're changing where things are being located. We will go more in depth with this, but this is basically if you have a pre-existing camera. We are going to be using the virtual camera and going back to this setup right here. So I just hit enter just to bring back that view. Sometimes if you click out, just as a reference, it can get a little confused and the visual may go away. So you're entering a mode, and when you select a different node, you're exiting that mode since you're not on that node. So you just want to be careful of that. So we can see over in the viewport that we have some new information over here. So in the top left, we have the KeenTools tracker tool. It kind of lets you know that you're here. The Shift F1 can hide these hints, and these are just helpful hints. F hotkey to center the geo. You can create and drag pins with the left mouse click and remove pins with a right mouse click. Pan and zoom with middle mouse and scroll wheel, and the escape to exit back to 3D. Up above here, we're going to see all of the actual tracking buttons. So we have a couple of features here, for the tracking, refinement, creating keyframes, and clearing animation. All of this is just a consolidated version of what we're seeing over on the side here for tracking. These are all of the same button features, just conveniently over here so you don't have to go back and forth. So to begin alignment of our geometry, first let's go to frame 1 here. We'll just start at the beginning. We need to see our actual geometry. We've imported the file in here, but we don't see it in our viewport here, and that's because it's at world 0. And the problem is our virtual camera is also at world 0. So it's just on top of itself here. If I move the camera, we can see the geometry there, but we don't want to use this as our method of having the geometry show up here. We can click Center Geo, and this Center Geo button is also located in the top left up here with these icons as well. Alternatively, as it says down here in the help, we can use the F hotkey as well as up here. It says Center Geo, F key. So we can click F and that'll center our geometry. Now we can click on the geometry, as it says down here, click and drag to align geometry with the background. So if I start clicking anywhere outside this geometry, nothing happens. But if I do click on the geometry, we'll see that we get a green little pin here. Now, this first pin is going to allow us to be in 2D screen space. When I move this around, we are moving the actual object in 2D screen space, and that is relative to our virtual camera. I can just try to line that up right there. When I create a second pin, I now can do rotation and scale in that same 2D screen space. And I can align that up. And if I put a third pin on here, we can now deal with 3D rotations. And we can align this as well. We can also see that these pins are now red and this one is green. That is just showing you the currently active pin that you're working on. I can also individually right click on each pin and delete those pins like so. I can undo that for all 3 of those. And alternatively, you could use the remove pins button up top as well as on the side over here, which I will also undo. So in many cases, like we can see right here, it can be difficult to see our footage underneath this wireframe. So we can use some of the features up here where we can actually create pins, remove pins, but we can pan and zoom. If you're on a mouse, you can use a scroll wheel to zoom. If you're on tablet, which I am, you can right click to zoom and middle click to pan. So I can zoom this in just so we can get a better view of things. And this can help, but this still is a little difficult to see the footage underneath. So there is another feature over here. I'll scroll this down called appearance. Scroll it a little further. And this appearance will allow us to change the color of our actual geometry. So it's defaulting to this kind of neon green, but we can change that color. We can also change the alpha. We can actually make that more opaque, and we can actually reduce this. And reducing actually can be really handy in scenarios like this. So we can finally see the footage and see where those edges are to help us with alignment. For backface culling, these other options here, backface culling is basically any geometry that shows in through a open geometry here. So the back face of that geometry, if I turn this off, we'll see this is the back side of that geometry. This can obscure some details and be a little difficult to align. So turning or keeping this on really comes in handy. Lit wireframe is just the 3D lighting that's happening. So we can see some shadowing happening up here. Sometimes having that off can make alignment a lot easier to have full details. Sometimes with the shadowing, it's easier to have the 3D dimensionality. Use adaptive opacity. Now this relates to if I had, say we go for a low opacity here, and I was to zoom out. When I zoom out, this adaptive opacity is adjusting this fine alpha that I have set. So when I zoom out, it still kind of relatively stays the same. If I don't have this on, we'll see that that is not adjusted. So as I zoom out, it could be a little difficult to see the final piece. I'll zoom it back in here. The next one is pin size. So as we can see on the 4K monitor, these pins can be a little tiny. So you can adjust those to be larger or smaller. I have a tendency to keep them around 20 approximately, just so I can see them stand out really easily. And the sensitivity, this is basically the radius around these pins for sensitivity of clicking. So the wider that is, the more sensitive this pin will be clicked based on where my cursor is at. So I could have it way out here and click it, or I'd have to be a lot tighter to it. So if you have nearby pins that are kind of on top of each other, sometimes having a smaller sensitivity will help isolate one pin versus another one that's nearby. So let's finish aligning this. I'm gonna move these pins into position here. I'm gonna grab this third one, roughly about in there. And I'm clearly not lining up here, so I'm gonna put another pin on here to bring this over. And we're gonna notice something. Even when I align this up here and say I put another pin on this side to bring this in, we're seeing this blue pin now, and there's a dotted line. What this means is that there's a conflict. The positions of the pins that I'm setting are conflicting with the data that the camera has. The information doesn't work. The shape and these positions aren't going to work for this particular geometry. And this is relating to the focal length of the camera. Right now we have a default of 50. So if we go back up to our virtual camera settings here, we'll see our focal length is 50, but then there's also this feature above here called Estimate Focal Length. If I turn this on, if I have 4 pins minimum, so the first pin or one pin that's active is 2D translation, 2 pins is the 2D rotation scale, and then the third pin gives us the 3D rotations, while the fourth pin will allow us to do the estimate focal length. And if I start dragging this in, if you keep an eye on that focal length value up there, you're going to see it change. So as I start dialing in this alignment here, we will see that number adjust accordingly to kind of help give us a better estimation based on the positions of the pins that I'm setting up here. So we can dial this in. It's still going to be just a smidge off. I mean, the geometry is only so accurate. So we can get the alignment pretty decent within this range here. So we can see the focal length estimated at 25.103. You could round this off if you wanted to, but it's ideal to stick with what you have because this is based on this exact alignment. So if this looks good, keep with this number here so the solver can actually keep this maintaining this information across everything. We do want to uncheck this so we don't continue to estimate. Alternatively, if this was on and you forgot, if you step a frame forward, it'll automatically turn off for us, just like so. Okay, so now that the geo is aligned, we can start tracking. So if we take a look at the track icons, these 5 right here, as well as the duplicate controls right up top here, we can see that we can track backwards by 1 time step. And this is a continuously track. This is backwards as well. And the stop during the track, and we can track forward continuously and track forward by a single time step. Now we're on frame 1, so I'm just going to track forward. What we're going to see while this is tracking is the bright keys are the user adjustment keyframes we've made during the geometry alignment process, and the darker keys, which are the auto keys that the tracker is actually making. Now, I was getting some pretty decent track times, even on 4K footage, so it's fairly speedy, and this analysis file is what helps with that, so it's always key to use that. Now, with any track, depending on how you've set things up, there is always going to be adjustments needed. So this is, tracking is never a flawless one-time kind of process. So we can see some alignment issues here that we will need to deal with. But first I want to show you under the transform tab here, the translate and rotate. These are the keyframes that the tracker created. So all of that data is the track data right there. The last scale parameter right here we'll talk about in a later step. But first we need to focus on refining and aligning this geometry. This is where the toggle pins feature can come in handy. Over in the tracking section, there's a toggle pins button here, as well as up top here. Now when I click this, we'll see that all of my pins turn yellow and they are now disabled. I can then make a geometry adjustment by enabling 1 pin and doing a 2D screen space translation. I can undo that. Or I can enable 2 pins and do rotation and scale in 2D screen space. Or I can also do 3 pins if I enable 3 and get back to my 3D rotations. So we can make adjustments like this. So I'm going to just make some adjustments to get this alignment back into place. And this should be good. I'll enable this 4th one. You'll see the conflict happening there, so I don't want to push it too extreme. And I'll try to get the alignment just about in there. And that's looking pretty good. So if I hit my left arrow key here and step back a frame, we'll see a little bit of a jump, especially on the ear here for the alignment. And that's because this will not blend, this adjustment will not automatically blend into the previous track. And we'll see the gap here a little more prominently where that jump is happening. So this is where refinement comes in. For us to make a refinement to this geometry adjustment we just made, we do want to make sure that we have at least 2 minimum 2 user keyframes. The first frame, we already have one there. And then of course the adjustment we just made on frame 200 gives us a keyframe here. The reason for this is because the refine process requires minimum 2 keyframes to do its process. And that's because it's going to track backwards and track forwards between those keyframes. It generates 2 animation tracks that's going to then merge as part of that solve. So let's take a look here, and we can see if I run refine, give it a second, we'll see that that snaps back into place, and that jump is now gone between these 2 frames. So let's take a look through here and see if we can find any more frames to make adjustments on, because I know it's not a perfect track and there's other frames that could be adjusted. And we're going to look for the kind of like more egregious ones. And I want to say there's probably more so in this area right here. I'm going to adjust my framing here, obviously, so we can see more. And I probably want to make an adjustment over here, and it could be just a slight positional adjustment. So I'm going to hit toggle, and then I'm going to enable one pin here. And it does look like I need to make a slight adjustment. So I'm going to enable this pin, and I'm going to then enable this one. And I'll need to adjust this one as well. Sometimes you can get away with one or two. It really depends on the movement that you have. So we'll make an adjustment here. And of course, now we'll have a slight jump between those, so we'll need to refine. Now, since we have more than 2 keyframes, the refinement process is going to act a little differently, logic-wise here, and that's going to be based on the position of the cursor in the timeline here. So I'm on frame 154, which is on a keyframe. If I was to refine here, it's going to go forward and backwards around that timeline cursor, and it's going to refine up to the next adjacent keyframe. So it would refine on both sides. If my cursor was in between, it would refine only from this keyframe to this keyframe. So it's forward and backwards around the timeline cursor. So I could refine here and have only this segment over here. So the sections between keyframes are just considered segments. And I could refine here, or I could refine here. Alternatively, I could say refine all, and that would refine both segments regardless of where my cursor is at. But if I kept it here, I can just refine, give it a second, and that'll make that adjustment. And I could step through and see if we have any more frames to manipulate here. And it looks like even on that frame, we could probably still tweak that a little bit further because that ear is a little further out. The coloring on the fox matches the wall, so it's a little tricky to see in some cases. Go ahead and refine that. And we'll come down here and see if we have any other adjustments to make. Could probably get away with a very minor one over here. I'm not even going to bother to toggle the pins. I'm just going to make the adjustment directly on these active pins. And I'm going to go ahead and refine. Okay, so we can take a look at that. Just kind of scrub through that. And that's looking pretty decent. That's a pretty solid track across there. Now that I have more keyframes across this entire timeline here, I can show you some of the functionality of these other features in here. So under the keyframe parameter here, under the tracking section, there's a little green plus icon. This is going to allow you to add keyframes. You can just click in the middle of somewhere and toggle and add a keyframe, like so. You can click the X to delete a keyframe, and that can be an auto keyframe or user created. You can jump between keyframes by toggling the forward and back here, so next and previous keyframe. Alternatively, then these two, you can have your cursor over the viewport and hold Shift, left arrow, right arrow to jump between keyframes as well. And this can be a little handier with the hotkey. This second parameter over here is clear animation. So as you're tracking, if it gets way off course and you decide that you really don't want to have those auto keys that it was misaligned way out there, you can actually clear the animation both behind where your cursor is currently at, or you can do it in front. So moving forward, everything from there. And that does take auto keys and user-based keys. So it's a complete delete. This little sweep here will delete everything. So if you want to start over from fresh. And then this little middle one here for in between will allow you to, if I put my cursor in between two keyframes, to actually take a section out. So this will keep the user-based keyframes, but remove those auto keys, like so. So I can actually go through each of these and remove those. And just to illustrate the functionality of refine and refine all, I could literally go through and refine between the two keyframes independently, like this. Or alternatively, just click refine all, and all of my keyframes will get refined, keeping my user keyframes in there, of course. And if I play back through that, we'll see we still have our track just like before, nice and solid. Okay, so we have our first track. Let's go ahead and hit escape over the viewport so we can actually see this in the world space. And if I just kind of navigate and move this around just so we can see world 0, this is where our camera is currently located, the virtual camera that we have up here. And if I go ahead and play that, we can see our geometry now has our track applied to it. And everything is moving in 3D space. Now, from a scale perspective, this may not be optimal for a sim use, be it as a collider or an emitter or so forth. We are kind of pushed out to the 20 unit mark here, and this is quite large piece of geometry in this particular case because of the solution that it's come up with here track-wise. So we can actually play with the scale parameter right here under the transform. Now, one thing to note is that this is done relative, it's based on the camera space. So we can actually scale up and down this geometry, and we'll see that it's moving along a certain specific line here, and that's because it's in camera space, is what it's relative to. So I can make this adjustment, be it if I go larger, and if I was to hit enter to go back in, our geometry will still look like it's aligned. If I went any smaller, and I'll move this so we can see out here, even if I went even smaller like so and hit enter to go back in the mode, we'll see that it still aligns. So this is an easy way for us to adjust the overall scaling of this object to use in any particular case that we want to have it for. My actual number I ended up going with was 0.16. And that gave me roughly about a 2 unit scaled geometry, and that was decent enough for most simulations that I would probably do on this. An alternate method to kind of talk about scaling here, we are at SOP level, the geometry context. If I go up one level, I'm going to hit U on my keyboard and go up, we have our geometry, which is right here, and that's what's highlighted yellow and selected. Another method is to use a null at the object level. And I can take that null and I can connect that into the input of this geometry. And that now means that this null, any transformation it has, so up here we have translate, rotate, and scale, as well as pivots, we can alter the transformations of our geometry as a whole based on this null. Now this is one particular workflow. It's a legacy workflow. If I use the scale here, we can see how that modifies things. If I use rotate, keep in mind that where our null is located right now at world 0, it is going to be the pivot point. So when I do a rotation, it'll be around that actual location right there. I personally, and in general, the industry overall, especially VFX and post-production, it very highly frowns upon using this method of transformation because the transforms that are right here, even the geometry node has its own transforms. All object level nodes have these. The primary argument against using these is that these transformations are not seen by processes in the geometry context. So inside of this, where we're building everything and doing the tracking on all of that, these transformations aren't natively seen inside there. And even with, like, say, an object merge, you have to manually select and tell it to even apply these transformations for them to even show up. So it can cause a serious amount of confusion when modeling and just dealing with modeling operations in the geometry context, as well as simulations, especially with being misaligned or even just not operating as expected inside of SOPs because of these extra transformations that are on the upper level here. So that's one of the key reasons of not changing those. These values are not natively seen by a lot of processes, especially inside of the geometry context. So transform stops inside of the geometry context are usually the current most popular way of doing transformations of any geometry and manipulations of geometry. You want to do that inside the geometry context. And this OBJ level should only be reserved and used for final scene layout or even basic animation motion that you would apply to the overall scene as a whole, if at all. Like I said, it's generally frowned upon these days to even use these transformations. But keep in mind that this is global. This is on the whole object. So if this was your entire scene, that's one thing. You can make those adjustments there, but just bear that in mind. Okay, so we have our track. So we probably would like to access the track data. So you might be thinking, wait a minute, aren't we already doing that? The GeoTracker has this, right? Let me actually go back here. I'll delete this. This is actually from a previous attempt. I'll delete that as well. But I'll go inside here and select the GeoTracker. And that's technically true. We do have the track data. The translate, rotate, and scale is all right here. But this is also packaged with the UI for the tracking system. So we have our virtual camera, we have our masking, smoothing, and all of that. So this is kind of like a multi-use node here where it's the tracker itself. This is the tracking process. Ideally, we would want to export out the track data itself. And that specifically is what we want. This is just to do the tracking process. We then want the track data as a separate export to then use for whatever we want. So under this export tab, we can see we have export transform, and then there's a checkbox here for linked. I'm gonna go ahead and click link, and I'm gonna click the export button. And what we're gonna get here is a transform node. If I select that node, we're gonna see the transform, rotate, and scale parameters are all linked. They're expressioned to point over to the GeoTracker. So these are literally pointing to these three values. So this immediately gives us access to the track data only, and we can apply, right now it automatically wires it up to this geometry, but we can easily cut that and attach this to any other geometry. Ideally, this would be a high-res geometry. So say you're going to be tracking the proxy, and then you would connect up the high-res geometry to the actual track. That would be one use case scenario in that. This is handy, and it's great if you're keeping everything in the project file. If you are at a studio and you are the dedicated tracker, so you are doing the tracking and then handing this off to another artist or another machine or another project file, whatever it may be, ideally, you don't want to have in a large pipeline the need for a GeoTracker license on every single machine when the tracking process is only occurring at the tracking station. So this is one thing you want to try to avoid. And the option of doing this as unlinked, so where it's defaulting to unlinked and transform, if I click export, this is going to create exactly the same thing. It's another transform, but what it's doing is it's baking the keyframes. So our translate, rotate are all baked in there. There's no expressions. We have the default Bezier function that's in there, and you get that with all keyframes. But the keyframes are baked across the entire bottom here. The uniform scale is just set to match the same scale that we set here. Now, if I was to change this value and go to a different size, if I go here, this will not update because it has been just baked. There's no connection. Whereas the linked version will have that same value. So the benefit of having the unlinked is that this is portable now. So we can literally, I'll take this back to my original scale. We could take this track, export out this track data, and this can be isolated to only the tracker's project. This can all be removed from the copy of this to then pass this unlinked version out to be used by another artist on a different machine that didn't have a license. So we literally can use this, like I said before, for a proxy for tracking and high res for the actual track. We can even use a completely different geometry. This is kind of a boring little box, but if I was to connect this up and export this out as, or display this, we can see the box is now taking the place of the fox head, and I can play this along. We'll see it move in the same way. I'll even template, I'll do it on this one here, the fox head, and we can see the alignment of that and how this is all linked together. This is another proponent of why you build everything at world 0. So your assets start at world 0 so they can then more easily be placed afterwards. And this tracking is no different in this particular case. So this can be just about any object. So if I put in the rubber toy, I could have the rubber toy go inside here and it would move the same way. So we have our geometry, we have our geometry track, but we're missing one key component, and that's a camera. Now, we used a virtual camera, and I'm gonna clean this up a little bit here. Select these, get rid of those, and just make my original track here active. We had a virtual camera that was set up here, but we don't have any physical object in our scene. Like I don't have a camera up here to select. And that's because this virtual camera is virtual. It's behind the scenes. It's there to exist to allow the tracking to occur. Now, the problem is our track is only valid based on the perspective of this virtual camera. Without a physical camera, this track is pretty much meaningless. It's just motion, but it has no context to the alignment that we have here when I hit enter, the alignment to this footage. So we do need a camera. I'm gonna hit escape on this real quick. And to go back down to our export here, the export transform that we did earlier also has two more options. There's a tracked camera and a virtual camera. Now the tracked camera is basically using a geometry track as camera motion. So you can extract a moving camera from a geometry track. And the virtual camera is just basically a static camera. This is the virtual camera that we've been using. So if I select virtual camera here, delete out this path, the default on this, if I control middle click, is /OBJ. We basically can select a network to send our camera to. So we can have this export go to our object level. And we can also make it linked. So this is the same as the transform where we have linked and unlinked. So the camera parameters would be expressioned. So if I click export and I go up to my OBJ level, we'll now see a camera that is up here. And if I look, we'll see that all of these are expressioned. So all of the translate and rotate are expressioned for that camera. We also now have access to the camera. I can select that and we'll see our footage because that is also added by default. The camera background image will see the same path to our footage as well as the focal length, aperture, and clipping are set up. And if I was to play that, we'll see that this all lines up. So our geometry now has a valid camera that we can see and render from. If I go back inside here, we can, like I said, change the network. So instead of the OBJ level, we could go to the stage level. And I could say accept and export. And if I was to click here and go to my stage, we will see, give it a second, our GT virtual camera. And it's going to have the same information in here for the background, as well as clipping and all of the information in there. So let me go back up to object level and go back inside. And for the other option here, stage, you can use a LopNet. And a LopNet is just a kind of backdoor to stage, essentially. If I double click and go in there, we're in the stage context. We have access to karma and everything, even though it's being done through the Lop node. So we can take our GeoTracker and I can select under object. I can find the foxes tracked and look for my LopNet 1, click accept, and then I can export to there and I can go inside and we now see our GT virtual camera inside of there. So we have multiple options to actually export cameras out. So this is very handy that we can do this linked and unlinked. Okay, so what if we wanted to track multiple objects? We obviously have two fox heads here, and we've tracked the one on the left, but we want to track this one on the right as well. So I'm going to take both of these nodes. I'm just going to scoot them out of the way off to the side here. And I'm going to take the file node here. I'm going to Alt, left click, drag, and this will make a copy of this node. And I'm going to change our geometry file. We obviously don't want the fox left. So I'm going to click the selection here and we want to choose the fox right. And I'm going to do the same thing. Alt, left click, drag the GeoTracker and connect that up. And on the GeoTracker, we need to do a lot of cleanup here because obviously this is the old track data for the other side. So we're going to work our way down the list here. So the image sequence is going to be exactly the same. The analysis file, we do want to update this because currently, since the naming is using $OS, this is grabbing the node name. That would mean GeoTracker 1. Now, I can't have duplicate names. Houdini does not allow this, hence the 2 on here. It increments the number up. So GeoTracker 2 isn't going to exist based on this expression. So we're going to click the file here, and we're going to look for GeoTracker 1, and specifically the one that is foxes _2. I've done this multiple times. So this is the file that we want. And that will now take care of our pre-calc. Our camera is no longer virtual. Since we've already exported out, we're using the GT virtual camera. We're going to change this to object/lop. And all we have to do is now click our selection here and look for our object level. In this case, I'm going to use the object level, the GT virtual camera. And I can click accept. And that's now going to use this camera instead of a generic virtual camera. We do have animation in here, so let's go ahead and clear out all of this animation. And we don't want, actually we'll keep the same scale because this is probably going to have the same scale alignment as our other one. And we should be good to go from there. So export, we'll deal with that in a little bit. So I want to select my geometry tracker. I'm going to enable it and I'm going to hit enter and we're going to hit F to see our geometry. Now, just because it may or may not have been cleared out, just for sake of safety, we're going to remove pins because we did have pins on this left one. So I'm just going to click it just to make sure there's none existing outside of where we're looking right now. And if I left click, I should be able to start aligning this. I'll zoom in a little bit so we can see it a little better and start clicking our 3 pins to get the alignment as best as we can here. And since we've already pre-solved the camera here, our focal length should be good to go. So we shouldn't have too much of an issue to align this geometry. It's pretty much a good match across the board here. So some slight adjustments, but we should be good to go. And that looks pretty good. So I'm going to go up top and we're going to track forward since I am on frame 1 here. Track that forward and let that go. Now we'll probably have the same drifting issue just because it's based off of the same track algorithm and it's the same analyze file. So I'll make a quick adjustment at the very end here. We won't go too deep into this because we've already done these steps before, but we'll do a quick little refine and then take a look at the results. So on that last frame, we can see definitely that misalignment right there. And I'm going to toggle the pins and I'm going to do a positional alignment, and then I'll do a slight scale there, and then I'll do the 3D based off of this. And the nose is looking pretty decent. I might tweak that just a little bit there. And that's looking pretty good. I'm going to scroll up, hit refine, and that should now smooth out that movement. So if I was to zoom this back out, I'll actually hit escape here. And this should be moving just fine. So yeah, we've got a decent track on that, even just with 2 keyframes. There probably is a little adjustment that could be done in between there for more specifics. But to now see both of these in context here, we're going to take the first GeoTracker. Let's scroll down here. And we're going to do an export, transform. We'll keep it as linked, and I'll click export. And I'm going to come over to this GeoTracker and do the same thing. So export, transform, linked, export. And now we have our 2 tracks. And what I'm going to do is select both of these, Alt, left click on the output and drag, and that's going to give us both wires. And if I lift up my cursor, I'll get a merge. And that merge is now going to allow us to see both objects as one object now. And if I play that, we can see these moving with our tracks. And our scale seems to be just about right. We can adjust that scale, of course, and scoot this one back if need be. If I was on this one here for the right, I can adjust that track and push it one way or another. I'm just going to keep it at the same scale because I believe that still works with what we have. And to see it in context, we can now go to our GT virtual camera, which has our footage, and we can see our final track of both heads for these foxes. So those with a very sharp eye are probably noticing that this is a handheld shot. Now, ideally, especially in a production scenario, baking in camera motion into an object track is a very big no-no. It's not something you want to do. Baking in camera motion will actually cause problems when it comes to simulations, be it in emission from the geometry, or if it's the geometry as a collider. It will also cause issues when it comes to render time as far as motion blur goes. The velocity is what gets baked into the object. And it won't make sense if the object barely moves, yet there's a large camera movement. There'll be this really odd motion occurring on the geometry itself. So normally this is a very bad thing to do. So in a smaller movement scenario like what we have here, the heads are moving around quite consistently, and when they are kind of still, so is the camera for the most part. So the motion that's being imparted on these is very minimal. We can probably cheat this. And in reality, sometimes you don't have a choice. There's budget constraints, time constraints, and so forth that limit you from being able to have a separate camera and so forth. So that is one aspect of GeoTracker that I'm going to be showing later in this tutorial series. And that's going to be how to extract a camera, an actual tracked moving camera from the footage, and then track the geometry independently of that. So you can actually have 2 isolated motions. And that's the actual professional production way to do tracking in the industry as a whole. But as you can see right here, we have a pretty decent solid track for both of these heads that are good to go for simulations. In this section, we're going to go over how to export a tracked camera using the GeoTracker plugin. So let's begin by first saving our project, because we don't want an untitled project here. It's very important that we save it. So we'll say save as, and we'll navigate to our folder. I already have a file in here. I'm just going to save over that. We'll just call it roof track camera. Click accept. And we want to verify in our global animation options down here that our frames per second is 24. We'll set the start and end when we get our footage. So let's begin by putting down a geometry and naming that roof track. And we can select that, click I on the keyboard and dive inside of it, or you can double click. And let's put down a file, SOP. And for our file, we want to click our little file icon here to load, and we want to navigate to where our roof.obj is located. Click accept. I'm going to turn off the UVs. They're not good in this particular case, but all we want is the geometry. So we can see what this geometry looks like. It's just a basic roof with kind of a chimney stack over here. Now, just for visibility, I'm going to click D on my keyboard, click on my background, and I'm going to choose dark for the background there. Just makes things a little more visible. I'm also going to turn off my grid temporarily. So select the file and let's hit tab and put down a GeoTracker and shift enter to automatically connect the wire there and to activate our GeoTracker node. We need to get our image sequence. So we know we're dealing with 24 frames a second. We've already set that up. The image sequence itself, let's click our icon here and look for our source and find the roof underscore and then the $F4. That's just padding. This is 1 through 201. So there's 200 frames. Let's click accept. And then we can click the frame playback range here. So we can set that. And now we can see our timeline says 1 to 201. So from this, we do need to analyze. So we'll click the analyze button here. And the from and to frames should match 1 to 201. Let's click OK and let that analyze. Now that we have that all analyzed, make sure we select our GeoTracker, go to the viewport, click enter, and we can now see our footage. If I scrub through that, we can see what this is going to look like. We do want to find a good frame here for alignment, and it looks like this last frame here is probably going to be best because we can see the two extreme corners here, which would be ideal. So let's align the geometry. First, we need to click F over the keyboard or over the viewport, and we should see our geometry kind of centralized. It's a little tricky to see it because of the lighting, so let's change the appearance here. I'm going to take the alpha all the way up to 1, and I'm going to scroll down here and turn off lit wireframe, and that's going to make this a little more visible for us. I am going to increase these pin sizes just a little bit. I usually like to go around 12 just because of my 4K monitor. It makes the pins a little easier to see. So let's try to align this. Left click on the geometry to create a pin, and just to kind of move things around because we're temporarily kind of getting things in alignment here. As soon as I put that third pin, I can start moving in 3D. And once I do that, I can remove all pins here to kind of reestablish some new pins and start bringing this into alignment. And we can just kind of dial it in like so. This pin goes towards the back, which is probably not good. So I can right click to remove that pin and create a new one over here. Now we can see that there's still some adjustments that would need to be made here because nothing's really lining up here. And that's because of our focal length. The lens on this, we're not too sure what this is going to be. We don't have a camera because we're going to be creating that camera. So let's go to our virtual camera settings here and let's turn on estimate focal length. And when we add a fourth pin on here, we can start to get an estimate of that focal length as we start moving these pins around to kind of align this a little bit better. I'm trying to align, even though my pin is here, I'm trying to align this corner across here. And I'll probably pull this one over about here. And this is looking pretty good so far. Might make some slight adjustments here. I'll put another one down in the corner just so I have it. Same on this corner over here. Just kind of dial things in like so. Cool. So just so I don't mess up anything here, I'm just going to toggle my pins to disable all of those pins. I'm going to uncheck estimate focal length here, and we're going to track backwards on this. Okay, so we do have some slight misalignment, so I'm just going to add another pin, say about in here, to kind of bring that in and just kind of readjust this a little bit. Just to try to get this alignment along the roof like how I had it. And kind of bring that roughly about there. That's looking pretty good. So now that I've made that adjustment, I have 2 keyframes here. I can go ahead and refine that, and that should fill in everything in between there. So now if I go ahead and play that, I'll actually click my real-time toggle down here. So this plays back in real time. We should see now that this is tracked. There we go. So if I hit escape from this and kind of pull out, we should see, if I turn my grid on, I'll do that. We'll see that the geometry is moving, and that's because we are in a GeoTracker. We are tracking the geometry itself. Now, ideally, we want this to be static because this house isn't moving. There's a camera that's moving. So to take care of that, we're going to go scroll down here a little bit to the export, and we're going to go and choose tracked camera. And the select network, we're just going to use the object level. We can actually select from the list right here. So you could do stage if you're in Solaris, or object level. I'm just going to keep it at object level. I'm going to choose linked, and I'm going to click export. When I do that, we're going to see our view come back up here. We're going to see a couple of nodes generated. There's a GT scale transform, and we'll see that the uniform scale is expressioned over to our GeoTracker, and that would be this transform right here. So if I made any adjustments on the scale, that would come over to this uniform scale right here. If I go up to the object level, we'll see that we now have a camera in here, and that camera is what's default selected after we run that process. If I go back inside and I just play this, we'll see that everything is again aligned to it. Our camera is now moving. If I move out of my view and we see our camera, if you don't see the camera in this view, it's because of the ghosting. So ghost other objects, otherwise hide other objects. And that's just showing everything that's on the object level. So you can ghost other objects and see everything that's displayed. So if I play that now, we'll see that the camera is moving and the house is not. So that's what we want, is a static geometry that's at world 0, which is where that file initially started. This was at world 0. So this is how we can get a camera track off of the geometry track itself. I do want to point out that the camera, if I go over to that, you'll see the expressions here, and that's because we chose the linked option. And if I go to the view, we'll see that the plate is also automatically put in there, and everything is expressioned across. So as we select our camera, we'll see the plate along with it. So in this section, we're going to talk about the masking feature, as well as smoothing, and also go over the track focal length feature. And what we're going to be tracking is this house right here. But the geometry that we have provided is also going to have an extension here for the ground, because we do want to try to latch on to some details out here, if possible, to help stabilize things. But we do want to avoid moving objects like these people that are moving around on the grounds. There's another individual down here, as well as these parallaxing objects. And the trees, both in the background and in this foreground over here. So these are all moving elements from the perspective standpoint here that can influence the track in a bad way. So we're going to mask those out. That's what the masking feature is for. And the zoom feature will help us get the right focal length from the start of this clip to the end of this clip. So let's go ahead and get started on that. Okay, let's start by first saving our project file. We always want to make sure we save this right away. And I'm just going to name this building number 6. And we'll just verify that we have our frame rate set to 24 frames per second. And that is correct down there. So let's put down a geometry. And we're just going to label this building. And double click or hit I to go inside. We're going to use a file SOP here. And select our file from this icon here. We want to find the actual building.obj. And what this is a very rough proxy of that building along with the grounds here. I'll turn off the UVs just so it's a little easier to see. So we have all of this extra geometry down below. This is to kind of help stabilize things during track, but we will mask out some of this for the problematic motion areas. So from that, let's go ahead and put down the GeoTracker. So that'll be under KeenTools. And I just Shift Enter to attach this directly to the one. As long as this node is selected when you hit Tab, you can Shift Enter to then automatically wire it. So let's load up our image sequence. We'll go to our source, grab our building zoom F3. We can see that it's 1 through 239. We'll click Accept. And we will set our playback range here. And now we can see our timeline is now 1 to 239. Let's go ahead and run that analysis file. Since we've saved, we should be good to go because that's going to go into the correct folder. And we'll let that run through. Okay. So virtual camera, we do want to stick with that because we don't have an existing camera. And we'll toggle this down just so we can see our options for that. I'm going to select GeoTracker, click Enter. And I do want to adjust my geometry here. Let's kind of do an initial alignment. I'm going to hit F. And our lit wireframe here is kind of causing some visual issues. So let's scroll down, click Appearance. And I'm going to turn the alpha all the way up. And I'm going to turn off lit wireframe. And that's going to make things a lot more visible here. So I can zoom this in. And let's start pinning some corners here. Take this corner down to here, and we can probably take this corner back over to here. And we want to try to get this aligned as best as we possibly can. Now we're going to see conflicts happening. That's where that dotted line is happening. As I start moving multiple ones, we're seeing that dotted line. It just means we have a conflict. And that's because our focal length right now is not correct. So let's scroll this back up and do estimate focal length. So we can move that in to make the adjustments that are needed. And I do know that this is a rough proxy. So the alignment on the front here may not be exact. But I do want to try to get this corner lined up on this back side over here and on this far left side over here. And I know that it roughly lines up with the front of this garden right here. So this alignment is looking pretty decent for what we need. So we do want to mask out, like I said, this foreground and background trees, the parallax that we're getting from that can mess with the track on this ground portion here. So a lot of this area we are going to mask out on the ground. We'll keep the building, but we'll probably mask out the whole back area, this foreground, possibly even over here because of the statue. but we will try to mitigate as many of the parallax issues as possible that could mess with the track. So I'm going to hit escape, and I'm going to make some space here underneath my file. I'm going to put down a group. That's just a basic group stop. I'm going to just activate that, and I'll zoom out my view here so we can see our geometry. And I'm also going to turn off my UVs. And just because that background is too bright, I like to change my background to dark, just so it's more readable in the viewport here. And I'm probably going to mask out all of the backside here along the top, probably the front here where that garden was, and along the bottoms across here. So what I'm going to do is first give this a name. I call it mask. And it's going to be on primitives because these are primitive faces here. And we're just going to click the little arrow on the right side here, and that's going to allow us to select. Now we have a couple of ways to do this. Right now the default is with a box selection. You can do a lasso, and you can also do a brush. And the brush tends to be an easier one to just kind of paint in where you want. If you let go, you can hold shift to then add more selections. And if you want to remove, you can hold control. And I can take out, say, this back corner. What I'll probably do is take all of this. I know I want pretty much the entire front here. I'm going to grab just those sections. And I'll grab the side of the house. I think for the most part, this corner is where that tree was. And I think the statue was kind of down in this area. So I'm going to grab most of this here, possibly there. I think there was a generator that was on that side. So I'll leave this corner open, and I'll leave this section open over here just to kind of give us some anchor points on the ground, as well as the building as well. And actually I'll add in this one. Not that it's going to be seen, but just for completion here, I'll add in all of those for the ground. Even grab that one there. There we go. So let's go back over the GeoTracker, display that, and come to our viewport and hit enter. So now we can see our geometry. To apply our mask, let's scroll down here. We can go to the mask section, and it'll say surface mask group. Click this drop down, and we'll see our mask in here. And everything will turn this kind of dark blue to show us where the masking is at. We can invert that if we wanted to inverse our mask. So we have that option as well. So that should help us here, masking out this detail down in the corners here. This one overlaps a little bit, but that should be fine. We wanted to get that corner just because of the tree over there and then this lamppost. We've got everything up front here. So we should be clear on all of these other areas. So let's make sure we are on frame 1. I currently have my animation editor open here just so we can see the actual footage tracks that are coming through here. And if I kind of like scan through this, we can see how that twists around. So what we are going to do, scroll back up here, and we're going to change our lens from fixed to zoom. When we do that, we'll see a new feature show up here, which is track focal length. Now we use the estimate focal length to set the initial sizing. That's where we got the 29.6396 when we did our initial alignment. But what the track focal length will do is now track that focal length and estimate it every single frame here all the way across. So it's going to try to keep pace with the focal length over the course of the duration of this footage. And it's going to set a keyframe for every single one of those. So if I actually just select focal length here, and we should be good to go on everything. So I'm going to track forward. And I'll stop it here, and we can see how it's drifting at the moment. And we just want to make sure that we turn on our track focal length. and then we should see a difference here. And you notice that no keyframes were placed in there, even though we have these auto keys down below. We have the user key over here that we set for the alignment. But track focal length, once we turn that on, and I track forward now, actually I should just clear out forward just to make sure we have clean information here. And I'll track forward. And now we can see those keyframes coming in. Okay, so now that we're at the last frame, we can obviously see some slight misalignments here that we do need to make an adjustment for. So we're going to click the toggle pins, and we're going to activate and enable one pin at a time here. Going to do that corner. I'll line up this corner here, and I'll do a third one here to get that perspective. And since we are trying to do the focal length, I'm going to estimate focal length here. So now my fourth pin is going to help me get this perspective. And we'll just try to make sure this lines up very closely to what we had at that first frame there. So we want to try to keep it along that line there and make sure these are roughly in that same location there on these corners. Primarily the back corner here, we know that this was going to align. We know that the front here was going to be a little bit off distance-wise just because of the proxy that this geometry was. So this is looking pretty good. So we can see obviously that we have a keyframe adjustment here where our focal length is now different. So we will go ahead and refine. And I'll zoom that back out. And we should now see a decent track overall. We do have a little bit of a shift in here for when the adjustment is made between these two tracks. We can further take this and smooth. So under the smoothing section here, this is not a post-solve smoothing. Just to note that. This is for the solver itself. So when we refine and when we are tracking, it's when that is occurring is that the solver incorporates the smoothing in here. Now there's some default values that were being used, but sometimes we do need to increase these a little bit. In my particular case for Z, and so we can see Z right here and X and Y. X is not too bad. Y does have a little bit of a jump in there. Z also has obviously a little bit of a shift. Rotation seems to be pretty decent overall. Focal length also seems to be pretty good overall. So it's primarily these other areas, but we are going to add some smoothing to all of the above just to really help mitigate some of the chatter that may be in there. If I zoom it in, we'll see a little bit of chatter. It's very minor in this particular case. But what we can do is the Z translation here, I can take this to 0.022, and the Y, X, and Y, I'm going to do 0.15. Rotations, I am going to take that to 0.22. And for my focal length, I'm going to take that to 0.2. And this will be just enough. You want to be light-handed with these values. If you were to crank this all the way up to 1, that would basically essentially mean lock down the Z. So it's going to be completely locked and it won't deviate from where it's at. And that's not exactly what we want. We want to smooth it, but we don't want to go too heavy-handed with it. So I'll just take that back to what it was. And all we have to do is click Refine. And we should now see, both on our Z, it's kind of smooth out a little bit more there, in Y and X as well. The focal length is kind of decent in there. If I play, actually, let me turn on my real-time toggle playback in here, the clock in the bottom left corner, and I'll just play that back. So we can see the track seems to be just a little rough in that area there. So we do have a little bit of a slide happening in here, and that could be coming from a couple of different things. So we could add in some more masking in here, and I probably am going to do that just to kind of smooth out this section. So I'm going to escape, go over to my group, and I'm going to click the selection up here, which is going to show me my previous selection, and then I can just shift and select. I'm just going to go heavy-handed with it, and I'm going to mask out all of this. We probably can get away with just the building. So I'm just going to remove all of that, go back to my GeoTracker, display that, and then hit enter over the viewport. And all I have to do right now, I have my smoothing already set up, is just go back and click refine. So let me bring up the Z in this particular case. I'll click refine, and we should see how that animation curve adjusts after this refinement. There we go. So that's definitely smoothed things out there. So if I play through this, we have a much more stable track. And that looks to be pretty solid. That's locked on pretty good. So in some cases, you may or may not need to mask out certain areas. So sometimes what you would think could help anchor stuff can contribute to the track being a little more rough. So this is where we kind of dial things in piece by piece. But this is how we use the masking, smoothing, and the track focal length features. In this section, I wanted to talk specifically about the smoothing feature that GeoTracker has. This is a slightly confusing feature, or easily to misinterpret. So I wanted to dedicate a very specific scenario to kind of help illustrate this. So the footage I have right here is just a buoy on water. I made some generic proxy geometry to track this particular piece of this object here. And if I go back to the beginning here and I hit escape just to look at the result of the track, and I play that through, we can see a fair amount of kind of like jitter that's happening here. And if I look at my animation editor, I can step through these, the translate X, translate Y, all looking pretty good. Translate Z has quite a bit of noise in it. So we can see a lot more chatter there versus, say, the Y and the X. If I go to the rotate X, Y, and Z, those are also fairly good. There is some slight chatter here and there, like in this section. But this is something that I wanted to explain in how this can be mitigated and kind of cleaned up. Now, the key thing here is to note that smoothing is not a post filtering. To smooth after the fact and basically take what you have resulting wise and basically smooth it out, you can use a chops filter if you wanted to go that route. What this specifically relates to, all of these, the Z translation, XY translations, rotations, and even focal length, relate to the solver itself. These are weighting values that the solver will use during its tracking process and will adjust accordingly. Cranking these all the way up to value of 1 would essentially lock this particular axis. So Z would be locked. If I did this, X, Y, and Z would be completely locked. So only rotations would end up happening here. So you do want to be careful with how far you go with these. They are quite touchy. So it does take a light hand approach to smaller increments in this case. But as we can see, these values are a little bit jittery at the moment. So if I wanted to smooth this out, I would basically refine this. I can either set these up prior to doing my track, or once I've done my track, I can refine, be it refine or refine all. Refine all being the different segments that we kind of talked about with the keyframes. If you have multiple keyframes in here, then the refinement occurs within that segment of those auto keys. refine all would do all segments. I only have 2 keyframes in this particular case, so it's going to refine this entire duration from one keyframe to the other. And in this particular case, a Z value I found of 0.30 seemed to be pretty good. Now, if I refine this, keep an eye on this curve down below. And it's first going to lock it since I was not in the GeoTracker mode. And if I click it again, it'll now do the refine process. And once it does that, we'll see some slight adjustments that occur in here. Now, if I take that up just a smidge more to 0.38, and I'll click refine again, we can see how much smoother that solve gets. So you can see just the small increments. I went from 0 to 8 in this particular case. That subtle increment made a dramatic difference. So it is a little bit of a hunt and peck to kind of dial it in, but this is what you would play with to kind of smooth things out. Now, my final results in here, I ended up getting 3.8 for this Z translation and 0.3 for the XY translations. And for rotations, I also did 3.8 in here. And if I make those changes, I just now click refine, and all of these will be refined. And we can see how that kind of smoothed out a little bit more. If I hit escape, and I now bring it to the side here to kind of see the motion, and I play through, we can see that this is way more smooth. So I wanted to just kind of illustrate the smoothing in that regard. Now, when it comes to focal length, this will only matter under here when the zoom option is turned on, and more specifically, the track focal length is active. When you track the focal length, then the actual smoothing will occur on that feature when you're tracking the focal length there. So just keep that in mind when using these features. I can remove all of that off of there. And this value has no bearing if that mode is not turned on. So this value won't mean anything in this context because I do not have that feature turned on. So just keep that in mind when you're playing with the smoothing options. In this section, I'm going to go over how to use an existing camera from an outside source. The sourcing could be from another studio tracking department, an artist that's freelancing, or even you did the camera track yourself outside of Houdini. I'll go over the import process and then how we use that camera in the GeoTracker workflow. Okay, so before we get started, we want to do 2 things that are very, very important. One is save our project, because right now it's not saved. So we're going to go up to File, Save As, and we're going to navigate to our folder. Inside truck here. I'm just going to replace my file here. I'm going to call it truck 2. Click Accept. And the second is making sure our timeline is set up correctly. Right now it's 1 through 240. And if I click on my global animation options, it's the bottom left kind of icon right there. We'll see our frame per second is 24. That is the default. But in our particular case, our frames per second is going to be 30. So let's make sure we change that to 30. When we click out of that, we have to click Apply FPS. And that's going to apply that. We'll see that it changes our actual timeline here based on that frame rate. Now, this is going to be set later, so I'm not going to worry about that too much. We'll click Close. And I'm going to show you 3 different formats to import an outside camera or scene, which is going to be FBX, Alembic, and a command script, CMD. This is a native Houdini script. So we're going to start by going up to File. We're going to go to Import, and we'll see Filmbox FBX. Click this, and up top here, we can select our file, and we look for the FBX file. Click Accept, and it'll bring that path into here. The default settings are okay. We'll click Import, and what we'll get is this subnet. And the subnet, if I go inside by just double clicking here, is the entire scene structure. This will have the camera as well as all of these reference objects. If I kind of change the view here, we'll see we have a truck, a figure, this road, these tracking markers. If I scoot around to this side, we'll see the camera over here. And on this side, this is the back plate for that camera. The FBX carries all of this information through like that. I'm going to click D on my keyboard and go to the background tab and change my color scheme to dark, just because that darker background is going to help see these elements a little easier. So all of this geometry can come in as a reference. All of these nodes in here, you do not want to mess with. These are here for reference. We can object merge any of these elements as long as they're separated out into any of our other geometry. So this is imported to then use and reference however we like. So that's FBX. If I go back up to File, Import, and go to Alembic Scene, this is how we can get Alembic cameras into our actual project. There is an Alembic SOP, which is going to be for Alembic geometry, be it animated or static. But if you have a camera, it's going to come through the Alembic Scene. So we'll click that, and we'll have the same thing. There's a file import here, so we'll click that, select our ABC file, and click Accept. And one important thing here is the frames per second. We need to make sure that this matches our actual 30 frames per second because our timeline is 30 frames per second. So I'll click Import on that. And just to re-verify, we do have 30 here as well. So that is very important for the Alembic, especially because the mismatch of frame rates will definitely mess with the animation. And we'll see that we get the truck, figure, road, and in this case, a camera. Now, all of the other elements are not in here, like the tracking markers and the background plate, and that's just a byproduct of what that file will handle and what has been exported from it. We'll go ahead and turn both of those off. So that is Alembic and FBX. I'm going to move these off to the side here, and we're going to do command script. The reason I'm moving it is because I know there's going to be a bunch of nodes that get imported. So I want to have some space here. So I'm going to go back up to File, and instead of Import, because the option for command is not under here, command is a script. So we have to go down to Run Script. And this is where we run a command. So it's a command line script. Same thing. We click our file selection here, find our command.cmd file, click Accept, click Run, and now we'll have our import of our camera and all of these nulls. These nulls are tracking markers. So we'll see all of these tracking markers in the scene, and we'll see our camera off to the side here. So I'm going to Control A to select everything and make sure that I do not display it. And I tend to also turn off the selection as well. And that's just so visually this doesn't get too cluttered in the viewport, because these are all here for references. Now to select these cameras, we can go up to where it says no camera, and we'll see all of those cameras listed. So camera 1, we'll see here for the Alembic is the Ref Geo, camera 1 data. So this last one in the hierarchy here is the actual camera. And the same for the FBX. We'll see the FBX, camera 1. So we can select all of these. So that's the other tracking camera. This is the Alembic, and this is the FBX. And we'll see all three of those cameras match, which is perfect because this is what we want to use. Okay, so now we can set up our GeoTracker. So let's put down a geometry. I'll zoom this in a little bit here. And let's change the name of that to truck and double click to go inside. First, we need a file. We need our truck file. So let's put down a file SOP and go up to geometry file, select our file. Just move this over here. And we're going to look for the Ford Ranger small OBJ. Click accept. And if I was to hit H in the viewport, we should see that truck. So this is just a generic reference geometry. Turn off the UVs by just clicking this little icon right here for the UVs. And let's put down our GeoTracker. So I'll type in Keen just to get to it faster. And if I hold Shift Enter, as long as my file node was selected, it'll automatically wire everything up for me. So just like in the previous sessions, we need our image sequence. So let's select our image sequence, go to our source, find our sequence here, and we'll see that it's 1 to 87 in range. So we'll click accept, give that a second to load, and then we'll click over here our actual playback range. So we can set that. So now our timeline is now set 1 to 87. So we do have our project file saved. Let's go ahead and just save again, but it is already saved to disk. So now we can do our analyze. So I'll click that. 1 to 87 is what we want. I'll click OK. Okay, so now that that's analyzed, our camera, we don't want a virtual camera. We want to change that to object/lop. And that just means object level or lop level. And when I do that, we'll see we have a selection over here that we can click and now select one of our cameras. I'll scroll to the top here and we can see that we have our first camera, and I'll bring this over a little bit more here. And we have our alembic. If I click the plus sign, we'll see that there's all of these subfolders. And if I say camera one data, this is the camera object. This would be the camera that you choose, the one that has the camera icon. The previous ones are kind of like subfolders, so you want to be careful about which one you select. For the FBX, we can see the same thing. If I open that up, there's a camera one here. So this is how you would select the camera that you want. So I want this particular top one up here. I'm just going to click accept. And now we've connected our pre-existing camera to be used for GeoTracker. So now we can actually begin our geometry tracking. So let's begin by making sure we have that selected. I'm going to hit enter over the viewport and we can see our clip. If I turn on my real-time toggle here to make sure the playback is in real time, I can click up and we can see this playing through. I'll turn my grid off for a second here. So we can see our truck is traveling across this dirt path along here. So let's go back to frame one. I'm going to click F to get our truck here. Let's also change the appearance of this. We will take the alpha up a little bit here, the lighting we can turn off, as well as the back face culling. And this will give us a little more space to see this. Right now what we're getting is clipping from the camera view. So as soon as I zoom that in, we'll see that that now changes. We're just clipping through is what's happening here. So I'm going to right click to get rid of one of those and get rid of that. And I'm going to take a new pin and put that there. And I'm going to zoom this in so we can see our alignment a little better. Make another pin on this back corner, and I'm going to put one on the front here to bring that around. I'm going to right click to get rid of it and put another one further up. So we want to try to align this as best as possible. This is kind of a proxy geometry, so it's not exactly one-to-one. So we do want to kind of play with that. I might put another pin down below here to kind of straighten this out a little bit more. Try to get those tires aligned. It's more so about the ground interaction, give or take. The footage is quite compressed, so it's quite dark down here, so it's kind of hard to see exactly where that's at, but we want to get the general notion here. So we'll go ahead with that. And I'm going to save, always save as you're working. And now that we're on frame one here, we can actually track forward. It'll automatically zoom the view out as it does its tracking. And once that hits the last frame, there we go. I'm going to zoom it back in real quick here just to see how the alignment is. Any refinements that we do, I'm going to first toggle the pins. And that's just going to disable all pins, and I can reactivate them one by one as needed. So if I have to do a simple overall positional adjustment, I can activate one of these and then still position it without the 3D aspect of it. And I can then activate the second one and third one to then adjust the alignment back in 3D space. So we'll say that's looking pretty good. Now that I've made that keyframe adjustment there, I can go ahead and refine. And since I have 2 keyframes, that's the minimum requirement, it'll refine everything in between here. So that way, this should now blend between one keyframe to the other. And I'll go ahead and just play through that. I think we have a pretty decent track. So if I go back to frame 1, and I'm going to hit escape to get out of the tracking mode, I'm going to turn on my grid, and we're going to notice something. The way it's solved based on that camera puts our truck pretty far up into the sky. So what we do want to change here is a little bit of an adjustment. I'm going to go back up to the object level. I'm going to turn on my camera and then go back inside. And then what I'm going to do is turn on the ghost other objects. And what that's going to allow me to do, hopefully, is see where my camera is at. So any of the objects that are up there will be ghosted. Now, I do need a reference of my truck as well. So let's go back up here and let's also display the Olympic. And go back inside. And now we can see roughly where we actually want the truck versus where it currently solved. And there's a little bit of a directional alignment here we can see. If I look from like camera perspective, this is where the scale option comes in for the transform. So under this transform, these translate and rotate keyframes are automatically figured out for us from the solver, but we have the scale parameter. And this scale parameter allows us to make adjustments after the solve relative to our solved camera here to align. So as I scale that up, you can see our camera stays there and it's scaling based on that view. So now I can try to get this in basically aligned as best as we can get it. I'll just do some smaller increments here and we'll try to align it up roughly about there. Seems to be pretty good. If I zoom this back a little bit more and if I hit play, we can see that truck now is traveling along that road. Now, one of the important things about having a camera separated from the object as far as tracks go is because of motion. So the movement of this camera, which is a little tricky to see, so let's go back up top for a second, select our camera, go to view. I'm just going to increase the camera size here, the icon, just so this is a little more viewable. And we can see if I go to an above view here, play that again, the truck is moving relatively in a straight line, but our camera over here takes kind of an arc. So the path that this camera is taking, I'll bring up my illustrator here, is roughly kind of like so, whereas the truck is more traveling along this path. And we don't want this curvature motion baked into the vehicle itself or the object that we're tracking. We actually want this motion to be independent of the camera motion. And this is very important, especially when it comes to rendering. Your motion blur will be more accurate because the object's motion will be independent of a camera motion. And the same is going to be for simulations. When you use this object as a simulation to emit from or as a collider, if this arc motion is baked into that, you may get some very odd emission directions and collision directions. That velocity is going to be imparted in all of your motion, and you don't want that kind of extra motion from the camera doing that. Now, there are some scenarios where you will have no choice but to track the object with the camera motion. It's just an inevitability in some scenarios, but you want to avoid that if at all possible. So having the camera separate from the object. And with that, we should have a ready to use asset now that we can use for simulation, both collision and emission. In this section, I'm going to show you how to use GeoTracker to calculate an initial camera focal length, which will be used to set up a camera track that then can be used for a geometry track. For this example, I will be using the Solaris context. The methodology is still the same for the OBJ workflow and will work there as well. So what does this all mean? Well, first we need to prepare a plan. So the idea here is to, one, get an initial focal length for the virtual camera. Then two, use that value to help align the microphone to get a camera track. Then we can use that camera track to get a geometry track on the face. So we can use the face over here to acquire this initial focal length because of the details that are unique in this space here. And this will help us define that focal length a little more accurately. Now, the face will not be suitable for the camera tracking itself due to its independent movement from the clear camera motion that dollies to the right. We want a static object in the scene, which is the microphone, of course. And this is going to help us anchor and provide that static position that we need for the camera track. The reason to not use the microphone initially is because of its simplistic shape. These kind of simple shapes can be more easily prone to inaccurate focal length estimates. This microphone could be more oval shaped than circular for all we know. And getting these curves are a little kind of nebulous in our judgment as we put a shape on here. So having to guess at the overall size and shape of this object can compound the inaccuracies we introduce when making a geo for it. So we want to try and avoid this as much as possible. So after that static microphone is geo-tracked, we can then export a tracked camera to then use for the geo-tracking of the face. Okay, so let's hop over into Houdini. We want to grab our Solaris context from here, the desktop for Solaris, and that's going to give us the default layout that we want to have here. And first things first, we want to save the project file. So File, Save As, and then we want to navigate to our folder. Just going to increment this up to my next one here and save that project file. Now we can make a SOP create LOP. So if I type in SOP, we'll see a few options there. So SOP create, LOP just being the lighting operator kind of acronym for Solaris operators that we have. And in this SOP create here, I'm just going to go ahead and name this face. And let's go ahead and dive inside. We can scoot these up out of the way here and put down a file SOP, since we are now in the geometry SOPs context. So for this file SOP, we just need to select our file. So if we go up to geometry file here and click the icon on the right, we can look for our singer_head.obj, click accept, and we can see our singer head. Okay, so now we can set up our GeoTracker. If we select File, click Tab, go to KeenTools, and then KeenTools GeoTracker, we can click Shift Enter, and it'll automatically connect the wire for us. You can alternatively just drop that down and manually connect up the wire. So for the GeoTracker, we need to set up our image sequence. Let's choose our file, select the sequence, hit accept, and let's also set our playback range just to make sure that this is set to the right range here. So 1 to 122. Let's also verify that our frame rate is also 24. So in the bottom left corner, let's look at our display animation options, and we can see FPS is set to 24. So we're good to go there as well. So next we can do our analysis file. Click Analyze. And we can set the frame from 1 to 122, so we want the full range, and click OK. Great. So now that that's complete, we can try to find a good frame here. So let's select GeoTracker, move over to our viewport and click enter to enter the mode here. And let's scrub through our footage and see what would be a good frame here on the face. We don't want anything that's cut off like it was at the beginning there. His head is cut off there. So something kind of more full frame. We'll say somewhere around here at frame 41. So let's center our geo by clicking F. And we can put down an initial pin here to start aligning this up. And get the ear. Can grab probably the corner of his eye here to bring this around. Grab the other corner over on this side. And maybe one towards the top here. So we do want to try to estimate the focal length for this. So let's go ahead and click our virtual camera settings and click estimate focal length. So as we start adjusting this, we are going to see the focal length change over here. We want to dial this in as closely as possible. And it's going to be a little bit of an adjustment here and there. You can say something that's close to about the 55, 56 range. We'll say roughly about in there. Just make a few more kind of tweaks. And that's looking good pretty much across there. So we can say that this is our kind of initial focal length that we want. So let's click out of this, click escape, and go back up to stage level. And let's put down another SOP create. Throw it down on this side. And let's call this microphone. And go ahead and go inside of here. And let's scoot these out of the way. So we can start making a reference geometry for this microphone. So we can start with making a tube. Just click enter to drop that down. And from this tube, let's put down a match size. And what this is going to allow us to do, if I display the match size here, I'm going to hit H over my viewport so we can see the tube. Currently, it is centered in world space. And match size is an easy way to allow us to justify on X, Y, and Z. I'm going to use the Y. I'm going to say Y min, and that's going to put it on the ground. The reason for that is when we use the tube, we can adjust the height and not have it offset in a weird way. So we know if we align the bottom, we can always extend the height and it'll just stay aligned in our kind of known location that we want. Going to reset, and I'm going to right click channels, and I'm going to remove from channel list. That's what that little blue line was there. I accidentally hit shift when I clicked on that. So as I said previously, we are guessing here as to the shape of this microphone. It could be oval and we are looking at it from its widest side, or it could be circular. We are going to make the assumption and take a wild guess here and just say that it's circular and use this tube shape for this based on the perspective that we had from the actual footage. Now, as far as determining the height to width ratio, it can still be a bit more of a guessing game on top of that, but we can use the footage itself to help assist us in this regard. So the first thing you might be thinking is we would put down another GeoTracker here and load the footage like we did before, right? Well, let me show you what happens. I'll put down a GeoTracker, go to KeenTools, Shift Enter just to add that onto there. And I'll select the image sequence because we need to have that synced up before we can actually enter the tracking mode. And I'm just going to click Enter over the viewports and F to center our actual geometry. Now I'm going to change the appearance of this to be brighter. I'll just make it 1, just so this is more visible. And I'll try to align the geo as is right now. So we have generally the scale. We do need the rotation to be altered a little bit here. Let me click outside of that. Try a different angle here. There we go. To try to get roughly this kind of perspective that we have going in there. I would probably use maybe like one of the other corners here just to kind of anchor this out a little bit more. Kind of like so. And we would expect to be able to just scale this up. So first things first, if I was to select my tube, we immediately exit our GeoTracker tracking mode. So that's one of the issues there. Any updates we make will show up. So if I was to change the height, then I can come back in and we would see that height. But ideally, we would like to see this both simultaneously. I could try even pinning. So if I go to my tube and I pin, so I have the parameters, and then go back and select my GeoTracker, I should be able to now slide, but we're not going to have any live updates. And that's because of how GeoTracker works. You have to exit and then re-enter for the updates to show up. And this can be problematic in trying to build geometry like this. We want to see this live, and we can actually work around that by selecting our GeoTracker. And let me unpin this. I'm going to take our path here. I'm going to middle click to get the full path. I don't want this to be relative. I want this to be absolute. So let me grab that, copy it. I can middle click to bring that back. I'm going to escape from the tracking view, and then I'm going to click D over the viewport. Now, if you go to the background tab, you'll see all of our perspective, camera, top, front, right, all of the different views for the camera. For perspective, I can paste that path in there. Now, if I do the single frame here, it's just going to have only that frame, which is perfectly fine. That's all we need for one reference. If I click enter and I can close this, we now see that we can see this image. And if I'm on my tube, we can now adjust this in real time and align to this. So we can match the parameters now a little more easily. I'm going to change the radius to 0.3. This is a value that I ended up using initially on my overall size. And since we are in the perspective view, we can move our perspective around to kind of generally get our alignment here. And if we were to like zoom in a little bit, we can manipulate this. If we hit W for wireframe, we can also see our wireframe in here as well. So we can kind of maneuver this just a little bit here and there. And this has no bearing on the actual track. This is just so we can get a sizing of this geometry to roughly match this microphone. And we want to try to get something that's going to be in the realm, I think I had 1.24, if I remember correctly, on this, which would put us roughly about in here. And it's more about getting the aspect ratio, right? We want to get the overall sizing. I don't want to go too far down on this because technically these bars are not on the same plane as the microphone itself. So we will have some parallax that happens in there. So we do want to be careful about that. So I just want to try to grab the upper portion of this. So I just want to make sure I have geometry that's roughly within the realm of that sizing right there. So the overall detail, I want to give this more resolution. So my rows are going to be 10 and my columns are going to be 20. And what that's going to do is help fill in the polygon faces right in here. Okay, so we can now set up the GeoTracker. We'll get some viewport issues like this from time to time as we go in and out. Hit escape. Sometimes it'll clear it up. Usually once you click on one of the original node pins, it'll start adjusting. We're going to have to realign this anyway because we've changed the sizing. So I'm just going to go ahead and click F to center the geo. And I'm going to clear all pins. I'm going to remove all of the pins because we're going to kind of realign this up anyway. So we do need to set up the rest of this before we do the track. We already have the image sequence, but we do want to grab the analysis file that we calculated earlier. So let's click on here. We're going to go to our Singer 2 pre-calc. We'll select that. The camera itself will remain as a virtual camera, but we do want to update that focal length. So let's go back over to the face, select GeoTracker, and let's grab that. Let's copy that. While we're here, we'll go ahead and just turn off that estimate because we're not going to need that on. And come back over to the microphone, go to GeoTracker, and let's paste that value in here, hit enter. So now we know we're working with the right focal length. So let's again center this geo and let's remove the pins and do some aligning. So we can click this and I'll put a third one in here. Right click to remove it. That way I can just grab something a little more easier to control on the sides, kind of like so. And this is going to allow us to now align this pretty decently with what we kind of solved focal length wise on here. And I think if I'm going to right click this and I'll grab this one, try to extend it out just a smidge. Sometimes grabbing the sides can be a little more stable, which I might just try to do the corners. We don't need to be 100% exact here. We do want to just try to mimic the position of this. Now I do want this angle to be a little bit better because right now it's a little too high up. I want it a little more down to kind of follow that curve. So we're generally getting across that curve. Same with up here. Let's go ahead and we'll track this backwards. And just to anchor it, we'll put a keyframe there. And we'll go back to our frame 41 there and track this forwards. And let's place another keyframe on the end here. Just want to anchor this down. Let's also do some refining just to kind of tweak this a little bit more. So we can kind of bring this back in just a bit. And go ahead and click refine. We'll make sure we're on that same keyframe there. And this will refine just on this side over here. And that should help bring that in a little bit more. We don't need to be 100% exact here. We're just trying to get the general camera movement. And this is looking pretty decent. So now to get a tracked camera from this microphone GeoTrack, we simply go up to the export, which let's scroll down here and click export. We'll see export here. We go to tracked camera and we need to select a network. So we want to select our stage, click accept, and we want to make this linked. And we can click export. And what we'll get is a reference transform and static geometry here that's relating to the microphone itself. And if I go up to the stage, we will have a camera in here. If I hit H, we should see our camera. I can bring that up here. I'll hit H again to center it. And we should be able to see our camera up top here to select it, but you won't see it in the entries. And that's because of how Solaris works. Everything kind of needs to be connected, and the displayed node is kind of the starting point. Anything from that on up that's connected shows up in the node stream, which is also kind of activated within Solaris. So we can select both of these, Alt, left click on the output and drag it to create a merge, and then we can connect that merge up to the camera. And when we do that, as long as our camera is displayed, we'll see our geometry, and in the list, we'll see our camera. And if I I'll bypass the face for the moment because we haven't tracked that yet, and we can play through this and see. I'll turn off the grid so it's a little clearer to see through here. we can see that we have our microphone now lined up with the geometry. So now let's get the face geo-tracked using this new camera data. Let's dive back into the face here. I'm going to turn that back on, double click to go inside, and we're going to bring camera back to frame 41 here. We see our alignment's the same, and that's because we had set this up on our estimated fixed virtual camera. So we need to make some updates here. We will keep all of the same information that we have above, obviously the same image sequence, the same analysis file, but we want to change this now from virtual to an object lop node. So we can select our new camera from the stage. We can find the GT tracked camera, click accept, and this will now bring this in. Now, when I select my GT tracker again and hit enter, we're going to see some differences here, and that's because now the track for the camera, it's going to change this position. It's misaligned and placed where the microphone is, and that's because the camera extraction process is based on the solved GeoTrack. So that GeoTrack was done with the microphone, hence why the head is over here. So we're going to have to do a little bit of realignment to get it back to where it was supposed to be. So we can start by just toggling our pins for the moment, and that's going to kind of change the system here. I'm going to click to make one of them active and start moving it, and we'll start to see all of these kind of reactivate. We'll dial these back in. Turn off the grid because that can be a little in the way here. We'll also take our appearance back down. I think I had it to 1.4. It's not updating based on what we had previously. So let's do that and get the realignment back in here. Now we are not doing any estimation because that camera has already been solved for us. So we don't have to worry about any of that setup. We just want to bring this back into roughly where we had it before. Try to align his nose and get the eyes roughly about in there. Now, one thing we may have noticed from earlier is the way this footage is, he is singing. So we are going to have to deal with this aspect of the lower portion of his face. Thankfully, GeoTracker has a feature for masking. And as we can see here, I'll just kind of scrub this. This can help with moving parts like this where you want to mask parts of the geometry from contributing to the track. As we can see in the footage, the lower portion of their face is moving quite a lot. So let's make a mask for this geometry to ignore that lower portion here on all of these primitive polygons. All we have to do is select our file, hit tab, and put down a group SOP. I'll just drop it right there in the middle. Now, making primitive groups can be done both manually and procedurally in a variety of different ways, but I am just going to be using this group SOP. It does kind of show both methods all in one, which is why it's kind of handy. We're going to display the group here, and this is going to allow us to see our geometry. I am going to turn this back to, say, smooth wire shaded so we can see actual polygons in here, and that's going to make this a little easier to work with. So by default, the group SOP has a base group enabled. When I disable that, you'll see that that coloring goes away. And you can see the orange in the geometry spreadsheet here, and that's showing what's in the group. The name of the group is right up top here. We can go ahead and just call that mask right now, because that's what we want to call this. And we want to make sure that this is a primitive group. This is very important, because this is what the primitive polygons are. We don't want the points, the edges, or the vertices. We want the actual primitives. So a manual method is to select the arrow on the side over here and come over to the viewport. And when you do that, you should see, it's kind of a little tricky to see it in there. There's a little blue square lighting up as I hover over it. If I click and drag, you'll see that I have a selection box. If I let go, we have a selection of polygons. That is because of the selection mode up here. So we have like a box selection, there's a lasso, and a pen tool. And I kind of prefer the pen tool myself when selecting. So you can actually select your polygons this way, and then you click enter, and then it populates all of the selection that you have in here. So these are all of the primitive numbers. So that's one way to do it manually. I'm going to disable that. And as an alternative, I want to keep this a little procedural. So I'm going to keep in bounding regions. I'm going to click enable here. And there's a bounding box, and we can see this in red, that kind of populates this space. So we can use this to select polygons. So if I click Alt and rotate around here, kind of to the side a little bit, we can see that some of those are already getting selected on the back. This is just because of the location at world 0 for the sizing and centering of this particular box. So we do want to change the sizing and centering of this. Some other options in here would be a bounding sphere. And then there's also options for custom objects and volumes and so forth. These are all limited to points and vertices only. So in our use case, we can only use either of these two. So I'm just going to use the box in this particular case. And the one sizing that I found, you can middle click here to get the ladder to extend each axis, kind of like so, even in smaller increments for fine tuning, or larger increments to get it a lot quicker. But the sizing that I found that worked is 1.1 on the X and 0.636 on Y and 1.15 on Z. And this gave me a nice size box. I just need to now have it align where it's going to be on this kind of lower portion of the jaw right here. So we just need to now offset both the X, Y, and Z in this case to align this. So again, the sizing or the location for the center here, I found 0 on X and negative 0.45 for my Y and 0.8 for the Z. And this gives me a nice selection across here. Zoom that in a little bit more. And one thing to note is there's an option here called include partially contained entities. That just means any of these polygons right here that are just partially contained that aren't selected, it's going to include those. So if I check that, you'll see that those are added to the selection. And I'm going to go ahead and use that option right there too. Well, let's go ahead and connect this up. We can go back to our GeoTracker. And let's display that. And we are in the mode. Just to be sure, I'd like to hit escape and enter just to verify that we are completely in the mode. There are a few glitches sometimes where it doesn't like to show up correctly. And once we're in here, I'm going to close the appearance and open the mask section. We'll see surface mask group. And under the dropdown, we should see our mask group. When I select that, you're going to see blue coloring for the polygons now that are where the group was selected. There's also an option here to invert, so you can use the inverse of your selection as well. We want to make sure that we are using the bottom portion of it though. So now we can start our tracking. Let's go up top here and then we can start tracking backwards. And let's just anchor this a little bit and put a keyframe down. And let's go to frame 41 again and now track forwards. And let's do the same thing. Let's add another keyframe to anchor that portion of things as well. So if I scrub through here, should see a pretty decent track. I'll go ahead and just play it as well. There might be the need for some adjustments here and there. There is a little bit where it kind of goes off, I would say about in here. So we can say on frame 103, we can make a refinement right about in here. And try to line that up. And bring that in just a little bit. The forehead's going to shift a little here and there just because he is actually moving. So there's going to be some fluctuations, but we want to get the base kind of shape on that. So now that I've made this change, I want to make sure that I refine, but I want to keep the cursor on the keyframe so it refines forward and backwards. So I'm going to click refine on that. And that's looking pretty smooth there. If I scrub it through, looks like we go off just a little bit more over in this section. You'll probably get away with, say, frame 27 there. I'll put down another keyframe. And I'm going to middle click to kind of scoot here so we can see how it's kind of going off frame. And do a little more adjustments in here. Okay, same thing. Stay on the keyframe and refine so it goes to both sides. And that's looking pretty good. We do have, it looks like it shifts one more time in there. We'll say like frame 32. You can see a little bit of a gap right in this section over here. So let's do a little more refinement here. And we'll get as close as we possibly can. It's not going to be exactly one-to-one, but definitely try to refine it. I'd say that's pretty close because I want to make sure that this side gets covered as well as that side. I think we can get away with it roughly about there. It's kind of a happy in between the two. So same thing. Let's refine that. And if we step through that, that's looking pretty good. If I hit play, this is looking good overall. We've got a really decent track on the face. And I'll just go back to frame 1 here for a second. And let's take a look at the animation editor. This is going to show us all of the keyframes on the geometry. If I look at the translate X, the Y, and the Z, those are looking somewhat decent. The Y is definitely a little noisy there. The rotation on X, Y, and Z are looking decent in general too. The initial smoothing that was on here was set to 0, but this can introduce some noise. As we can see in the translate Y, there is some noise chatter happening across there. So thankfully there is a smoothing feature that we have right here. So there's a Z translation, there's an XY translation, rotations, and focal length. Now, these are not a post-smoothing solution. These are in camera space and relate to the actual camera track itself, or the solver that GeoTracker is using behind the scenes. So this is going to smooth on that end, and the result will end up with smoother keyframes for our geometry across here. So let's make some adjustments to this to kind of smooth out some of this noise that's in here. Now, during some of my experiments on this, you do want to go light-handed on this. Any values, this will go up to 1. So it's 0 to 1 on the range. 1 is basically the equivalent of locking down the axis completely. So there would be no Z translation whatsoever if you cranked it all the way up to 1. So you do want to be very careful with these values and not go so heavy with them. So I'm going to use some of what usually are the defaults, 0.01 here. And on XY, I'm going to use 0.15 and 0.15 for rotation. Focal length, I'm going to also change that to its default of 0.1. I can tell it's the default because it's gray. The brighter white is how Houdini tells you that something's been changed parameter-wise. So these smoothing values, I think we're going to deal with on this. So let's go back to our initial frame of 41 because we know that alignment was good. That's kind of where we started with everything, was with that. What we will need to do is remove these keyframes because I've noticed that there are some issues with pre-existing user keyframes when doing the kind of smoothing pass on this, that it will hang on these keyframes sometimes. So we're just going to retract this, and we want to clear the animation behind this keyframe and clear the animation ahead of this keyframe. And what we can do is now track backwards. And then we'll put that keyframe back in there and go back to frame 41 and track forwards. And we'll go ahead and put a keyframe there like we did before. And let's just take a look at the track in this regard of where it currently resides. So let me zoom it back a little bit here. We'll go to frame 1 and play that through. And we can see that it's fairly smooth. We still have some drifting, which is natural. I mean, we have some fast movement within the head shake here, and it's always a normal aspect to do some kind of refinement of a track. It's never going to be bulletproof every time, regardless of the settings. So you're going to have to intervene from time to time. So we can go back to those previous frames that we tweaked before, because those tend to be the ones where the fast movement was occurring, which one of the previous ones was frame 27 here. And it does look like it could use some slight adjustment on that. So let's grab the pin from up top here and just kind of slide that just a little bit. The ear is looking pretty decent. I might tweak it just a little. And that side's looking pretty good. So same thing, we want to refine. And that's going to go front and back around that keyframe. And let's go further down here and see how things worked out. It looks like 32 is doing that same kind of tweak in here, and that's because of that fast movement. There's only so much you can grab with the optical flow coming from the analysis. So it can overshoot and undershoot sometimes, and that's perfectly normal. So we're going to adjust this one again just slightly and kind of dial it in. I'll have to tweak a few of these just to kind of get this alignment roughly back to something that'll work. So this is probably as close as we're going to get. There is going to be some offset here because of him wrinkling his forehead a little bit, but this is pretty close. So we're going to refine that, and that should take care of that section. And let's take a look at that last one that we had. I think that was around frame 103. Yep, looks like similar in there. So we have the same technical issues of drifting in those particular areas, and that's just a byproduct of that motion. So we'll tweak these a little bit here and there. This left side's looking pretty decent. Take it down just a smidge. That's looking pretty good overall. Again, there's going to be some variance because of the geometry versus wrinkling that happens as we move our faces. That's always normal. And refine those frames as well. And we can see how that adjusts to the refinement, how the keyframes were shifting along there as well. Cool. Let's go back to frame 1 there and take a look at this in motion. Zoom it out a little bit. And this is looking pretty good. Let's hit escape here. Take a look at our 3D view. I'm going to hit H on the keyboard here, and we can see the head. I'll even turn my grid on just so we can see that in context here, with that head moving around like so. And let's go back up to stage level here. Now, I had connected these from an earlier attempt. So our stop create microphone is over on this side, and we have our face. So to bring these all back together, because of how Solaris works, the connections of all of these have to be in the same node stream. So we're just going to select both of these, Alt left click and merge, and then connect up to our tracked camera right here and display the camera, and we should now see both of our geometries in here. Now I'll go ahead and move out into the 3D perspective here and turn on that grid, and we'll see that our alignment is a little odd for what we would expect. And that's just because of how the scaling solved on the head versus the microphone independently. So we can adjust that by going back into our face, and we can go to our GeoTracker, go to transform, and we can actually scale this down and up accordingly. So what we want to kind of keep an eye on is the actual view in this case. So if we go back to stage, we can pin this view here, go back inside, and we can see this now in context. So as I scale this up, we can say the microphone is a little more towards his face in this direction right here. This makes a little more sense for him to be speaking towards this microphone, kind of like so. So now if we go back up to the stage level again, I can unpin that, select our camera, turn off our grid here, and we should be able to play through this. I'll open this up a little bit more. And we can now see our microphone and geometry tracked together, all relative to each other. And that's looking really decent. So we can now do some simulations on this. You could use this as a collider for something. You can now integrate this 3D geometry into your 2D footage. And we were able to get a geometry track, a focal length customized from that geometry, to then create a camera track and then do a geometry track from that camera solve there. But we've done all of this in Houdini thanks to GeoTracker. So in this section, I just wanted to go over a use case for the geometry tracker. In this case, we are using some footage to extract motion to then apply some movement to a simulation. So in this particular case, it's just a little rippling waves that are cruising across this surface here. So inside this buoy track SOP create, I basically just did the track, if I hit enter in here, of a buoy piece of footage. So you can tell that this is a vertical format video clip. And I just made some generic geometry, some proxy geometry to roughly keep this shape here. And I tracked this first buoy. Now, from that, I used the link transform export to get this transform data. And what this will do is give me the keyframes of that animation. So now I have all of this animation on here. Now the geometry I don't really care about. I'm just taking raw data right here. So all of this keyframe data is the only thing I really care about. So this translate and the rotate if I wanted to use it. Currently I just used the translate in this particular case. So if I go back up and I go into this wave sims SOP create, and I'm gonna scoot this up a little bit to create some space. I basically just made a generic collider, which is just nothing more than a tube that's closed on the other ends. And I just kind of placed it in a position to where this container would be. So this box that we have around here is just a generic kind of container that's being used for a flip sim. So this gives me basically this kind of collider within that container space. If I activate the flip solver, you'll see that we have these particles creating this sim. Now this is fairly low res. I'm only dealing with about 2.7 million particles, just enough to get some kind of resolution out of this simulation. Once I've done that simulation, I've obviously cached that out to disk, and I get this kind of movement. Now, the key thing here is that movement that I'm getting is in this get track transform. So I basically took that tube and I moved it from its world space over roughly negative 3.5 units in there. And then I've expressioned over the actual track data, the rotation and the translate. So this is the actual track data being applied to this random piece of geometry. So we get this natural movement from the footage. So we're just using the footage to get motion. We're extracting motion from that. This can be used for like handheld camera movement that you can apply to a camera as well. In this case, I just put it on a piece of geometry. And now that I have that, I just kind of move that back into position so it would align with this container location. And then did the simulation. Once I had that simulation, the fluid mesh was created from that. And that's where we get all of this detail right here. So if I kind of bring that down at an angle, we can see this rippling across here. So we can take kind of very natural movement from reality and apply it to a simulation to generate some more kind of dynamic and interesting and less programmatic feeling type of movement in a simulation. In this use case example, I just want to show you how pyro smoke can be emitted from a tracked geometry object. So in this example, I'm using the Singer example that I showed earlier. And I basically tracked the microphone to extract a camera. So there's a camera track done from the actual, just a basic tube. And I've gotten that motion and extracted this actual camera here through the export option of GeoTracker. Inside this Singer Smoke, I went ahead and did another GeoTrack of the actual face. I'll click D on my keyboard here just to make this dark so we can see things a little better, especially with volumes. They tend to disappear here on bright backgrounds. And this GeoTracker here, I did the same track for the geometry of the face, but I used the tracked camera that was exported from the microphone track as its main source. So that's the primary camera. That way I can isolate the head motion from the camera motion. I've essentially created that geometry here where I've taken the source geometry head and filled in the holes. The original does have some holes inside of it, like so, from the eyes and so forth. So I need to solidify that. So that head has been solidified as a geometry as well as an SDF for collision. And this is fairly low res in here, but this works just fine. You could probably push it a little further on the resolution. And from that, I created some field sources. I have essentially created a mask, created some rest attributes and so forth, but I created a mask across the face of this and a secondary mask that then grabs a certain side section. And then I combine the two together. And then from that, I threw in some noise just to mix it up, and I have it animated so the noise is now moving around the side of the head there. I threw in some random color here because this is the color I'm going to emit in my smoke. So I'm going to convert both this color and that other map into density, color, and then I'll also have temperature in here as well. Once I did that, I just renamed everything for that mask to density, and that gets adjusted a little bit further. And then I also set temperature from that same value. Once that's all been rasterized, I end up with a source like this for emission for my pyro solver. So those are my field sources. Then I go down into the simulation here. I'll show some of the quick settings in general. I'm just exporting out density, velocity, and color, the CD. And for my sourcing, I also have the density in here. I have also the temperature being pulled in here. Velocity is just being pulled in, or it's on by default, but there's no active velocity coming in. It's generating velocity, but I didn't bring some in. And the color is getting created in here. So this has to be added for the pyro solver to pick up on that. then it will output it here. Some basic parameters for buoyancy. I had the density and such affect it, as well as some wind and some turbulence, as well as some shredding and viscosity to kind of hold everything together and give it a more fluid kind of feel. From that, I get this. Now this dark or the bright area here is all of the other fields that are coming through, because I have density, velocity, and CD. So I'm just going to put down a blast real quick just so we can see the individual field here. So if I go for density and I invert this to delete non-selected, we can see the density sim that we get off of this, just like so. The visualizer is not on this, so we're not seeing the color, but this is the actual density that then gets colorized by the CD field at render time. So once we have that all together, we get something along these lines. The image doesn't always update in Solaris here when we scrub, so I'm just going to turn that on real quick, and we can see the smoke getting colorized right on there. So this is how we can take a geometry track and that geometry in 3D and be able to do simulations on top of that. If I scoot this view so we can see the actual exterior part of this, it's going to keep rendering the background there just because I have it set up to render that background. But we can see the geometry in here, which is being used as a holdout mat to make sure we don't see behind it when the head moves. So any of the smoke that's happening back here won't show up in the render. In this use case section, I just want to show you how to do some hair or fur, in this case, on the geometry that we track with GeoTracker. So in here, I'm in Solaris, and I have a SOP create. If I dive inside there, we can see that I do an initial camera track here. This is just to get a camera from the footage. So I tracked this little wreath in the background here. So that was used to extract a camera, of which then was used to do the independent tracks for each of the fox heads. So I'll turn off that grid there so we can see the fox head across for that one and the fox head for the right one. Did a track across there. If I play that, it'll be a little smoother. There's some caching issue here, so it's lagging on the back plate. So from this, let me escape from GeoTracker for a second just so I don't crash it. Open this up just to give it a little more space. So the left fox over here basically just did a rest and created a group for the kind of snout part of this, just to prevent fur from going into here. I knew that the mouth was going to be moving, so I didn't want any fur to kind of attach to that since this geometry does not animate. So I'm just doing it as a mask across the surface here. Once I have that, I did do a track here for the output, which is just a quad remeshed version of the geometry. And I have it this way because I want to solidify this and close up the openings for the eyes and for underneath. And that's so this can be a holdout mat during render, so I don't see any of the fur or the inside of the mask here when I grab shadowing and the fur that's on the back side here. So this is just a solidified version of that geometry. So from the group one over here, I just kind of split everything out where I pull just the section I want to put fur on, and I do some groups for all of the openings to end up with some curves that I then can use for some masking down here. If I turn on the mask, and we should be able to see if I change the name, because I basically renamed it. If I get rid of that, we should be able to see the masking that happens here. So I basically have a fall off coming off of those curves to basically create this gradient that prevents the fur from getting too close to the edges, and this is essentially going to end up being tapering. So it'll be full length out here and 0 length near these edges. So I can get that tapering of all of the actual hair that's on there. So put that back inside there, and this should now combine back into this. This attribute combined is now the hair length. I'll turn that on. So that mask gets renamed essentially after it's been combined, and I have some variance in here. So the blue areas being the smallest, shortest hair, basically 0 at the purple, and the longest at the red. So I get some nice variance for the hair length, and this is just a attribute that ends up driving that. So I have the tracked data applied to this now static or previously static mesh, and I have an SDF version of that same one for collision. That is used for a hair gen. And if I zoom in on this, the hair gen will generate all of the hairs, technically guides, but in this case, I'm using them verbatim as the actual hair and fur. I'm only doing 600, but that mask is what's used way down at the bottom here for unguided hairs. This hair length attribute that I made is what's driving the length of all of that hair. I basically do some cleanup over here where I blast out some minimal ones because they do have issues simulating. And I throw that into a guide process to frizz up everything. So I'm using the frizz option in here. I'll zoom that in just a little bit so you can see how that changes from straight lines to frizz. I create some pins, and that's going to be used for vellum to hold all of these hairs in place. I give it some hair constraints, and then I do the simulation itself. Once I've done that sim, I end up with this. And it's kind of floppy and moving around. Wanted it somewhat rigid, but a little loose, so at least it had some life and movement to it as the head moves around. As far as settings on that, nothing too crazy. This is literally the stock vellum solver, as is. Most of that happens on the vellum hair. So going with varying on the mass and thickness, I pin everything, I threw some drag on there, dampen the stretch, and then I also changed the stiffness for bending to 10 and also dampened that just a little bit in that regard. I basically repeat the process for the second head. So I'm doing the same thing, creating a rest, creating a group on there, which I just manually selected. So it's just all manual selections via the little picker right here. So I can just add those as need be. Did the remesh for the groups, did the dissolve to get the edges, and created the same masking. Slightly different pattern just because there's 2 different types of foxes, so I just wanted to vary it up. Created some color on this as well, so this color pattern is what's coloring the hairs, same on the other head. And also I have the same track, same SDF to have this collide, and did a hair gen on this one. And the difference on this one is that I did a hair clumping. So the clumping is what's giving it those spiky kind of feel to it. But I also ran a frizz on that, did the pins, and did the vellum hair constraints, and then simulated that. And this was a little more rigid in its settings as far as the bending and stretch, and this allowed for it to kind of wobble, but still be a little more life to it in that case. And that gives me basically this. So I now have 2 heads here. The geometry for the actual heads is what's going to be a holdout mat, and that's what allows it to basically block everything that's from behind. And if I just turn this on, I'll zoom that out. I'm using the backplate to render in here, as well as the render settings to set that backplate to render in the final image. So under image, use background on. I can turn XPO on. And with the lighting that I chose and the coloring, we end up with something like this. And I can zoom that in for a little more inspection on the different styles of this more fuzzy and this more clumpy kind of look. In this use case section, I just wanted to show a quick overview of tracking some vellum objects, hair, a head, and this actual scarf for a skiing kind of setup here for a little head replacement. So let me dive inside here, the snowboarding forest, and we'll go over to here real quick just to show the tracking. Just used a generic kind of tube and rounded it out as far as getting a head track in there. And I just ran that all the way through for this long clip. This clip is about 661 frames, so it is quite long. It's also in vertical format, but that totally works as well. Both vertical and horizontal formats work with Geometry Tracker. So I did a head track for that. And from that, I basically wanted to put in a rubber toy head that is essentially the static rubber toy test geometry. Went through a couple of like resizing and so forth just to basically crop out the head in this case, making a series of groups as well as some stitch selections in here. This is where the scarf is going to attach essentially, and did some remeshing, which I can show the smooth wireframe. So the head goes from quads to remeshed as well as being scaled to a more proper size for what was needed. So I have my head proxy here, and then I have my head high res, which is going to be over here. This is going to get deformed by the proxy. So the proxy is what's actually getting simulated. It's in a different location in 3D space here because of where things are going. But this is what's going to get simulated across here. I've applied the track that was gotten from GeoTracker here. And I end up with this base movement like this. And I essentially want to pin this and use soft pins so that way I keep this movement but add some looseness to it overall. The track itself, I just decided to do some post smoothing just cause, and that's just using a chop net. So the actual translate and rotate are right here, but the translate is coming straight from the tracker and the rotate is coming from the tracker but then being smoothed via a chop net here. So I'm just fetching the transforms for R, X, Y, and Z, running a filter over there, which is a Gaussian of 0.5, and then exporting that back out to the actual rotation in there. And that just helps smooth out the overall information for my needs and what I wanted to do in this particular case. And then I have a vellum constraint setup for shape match, for pinning, and then I vellum pack that. And that's because I'm going to have more than one object here, so I want to pack this to then merge in with another object on the side here. So I end up making the scarf off of the base of the head. So in this particular case, if I template that, you can see the base of the head. I'm just grabbing the geometry from there, basically making some curves, setting some attributes on there to create kind of a little ring platform around that, and setting a scarf height based off of that. So this is my collision that I'm going to use, and that's because of the body of the actual skier. I want it to kind of collide with something that doesn't exist. I don't have any 3D for that, so I'm just making this as the collider. The initial scarf, I start off with a grid that's just super long. So it's like a 5 by 0.5. Do some remeshing, give it some UVs. So just project some basic UVs on that. I'm putting on some extra little data in here. Shrink that down a little bit. There we go. Just grabbing some sizing, creating some attributes to use along the way. So I'm basically folding through a couple of transforms, doing a group to grab some of the seams in different spots. And I'm just creating this kind of semi-folded geometry like so. From that, I'm doing a deformed version, which is basically following a path. And that path is just a curve that I drew. So I'm attaching that with some resolution to kind of start a base shape that's going to be around the neck. I need to do an initial sim to kind of set a initial state for the scarf. So that's going to go through a couple of different things. I'm basically animating this scarf to snap out to the sides. This is what's going to pull the scarf together. So it looked kind of funky right now, but what it ultimately does is create this initial shape that I can start with. I can probably even just do a couple of frames here. There's a little bit of a pre-roll on it to give it a moment. I want to say it's about 10 frames, give or take. And that pre-roll basically is what's snapping this together in this case. So as that moves forward on both ends, it pulls the scarf tight. And then I just release the actual ends so they can fold back. So all of that gets snapped together. So yeah, there is a 50 frame and then I start at 61. So if I go back to 50 in this particular case, we can see how it starts here and pulls it tight essentially, and then snaps loose. So once I have all of that, I have my initial scarf shape. I'm doing some random adjustments here and there because I need to change the position and add the initial tracking information from Geometry Tracker. So I have everything kind of aligned in position here. And this gives me my initial scarf vellum source. And this is just the initial source. So you can see there's no animation that's happening in here. This is where it kind of starts. And this is where I kind of want to have everything in position, ready to go. So that ends up getting funneled together with the head. And this is my vellum source for the overall sim that takes place here. It gets unpacked, goes into vellum. I have some stitching that goes from the scarf to the actual head. Do some cleanup here. And the sim I get out of this is basically that. And the stitching makes sure it really ensures that the scarf doesn't take off too dramatically. I just leave the ends loose to flap around. I do have some proxy geometry here as a collision for the body. And that's just for the long part of the scarf and that piece over here, just in case they flap down, which occasionally it will, depending on the movement and everything. And I'm just trying to mimic the collision with that body. So it's real generic. It's a box bending polybevel, nothing too crazy going on there. Once I have all of that, I'm doing some more processing across here. With the scarf, I'm doing freeze frames and splits for all of these aspects right here. So for the scarf and for the head, I have also the high res. So this connection coming all the way up here, it's going to the high res and then the simulation. So I'm getting everything prepped and ready to basically kind of align and do a point deform to have everything, the high res move with the low res essentially. I split everything out from here. So I have my head animation, my scarf animation. This is what goes out to render. And from that, I export out each of those with some cleanup aspects on it. I did some smoothing and post-processing here. This is what goes out as a USD and is the ultimate final file that goes into Solaris. So you can see how the look of the original with that versus the exported version. And then the same with the head that I have here versus the original. There's not much of a difference happening there because there's no smoothing really. I'm just reducing the velocity and exporting that out for USD. Once I have the head over here that's actually simulated and wobbling around. This is the deformed version. So my high res that's deformed by the sim. I can now prep that for adding hair. So I just start creating some groups in here for where the hair is going to go. And then I can blast everything out. So I have just my hair section. Transfer over some mask attributes that are across here. It's just in this area, like so. And from that, I can copy that over to this low res over here. So this geometry and this geometry is frozen to the moving. I'm basically passing that over so I can then generate hair. And what I'm doing with the scarf, I bring that in along with the head as VDBs. And these are used as collision, essentially. So the hair is not going to collide. It kind of pushes everything out from there. Once I do that, I do some pins. And again, this looks kind of crazy and funky because this is just the raw source. But that then goes into a vellum hair constraint to then do a vellum sim. And I end up with pre-roll looking with something like this, flapping around with a lot of wind pushing on the backside to make sure that the hair kind of flows back. It's skiing down a hill, so it's super fast. I'm going to throw on some random colors here. This makes it a little easier to kind of visualize it. Ultimately, this is not the final render color. This is more for visualization, but I kept it anyway through the render, so that way I had the option to use it. I can visualize with the shader to see the open curves and my width, so I can see what the hair actually looks like versus the raw curves. And that's just setting the GL shade open curves. It's a detail attribute that allows the viewport to do that. And then I export that out as USD. On this side, this is the hair collider, which is just all of these geometries. That's for the vellum sim itself, so it's not the SDF version, which is for the hair gen up top. Then I have some flags for sun. Basically, I am using some geometry that just kind of rotates every so often and is basically mimicking the trees, shadows, and all of that. There's really nothing crazy going on with that. It's a basic grid. If I hit H here, and it's just remeshed. I randomly call out some of these pieces here, the primitives, delete those out, apply my tracking, and I have a second grid that's solid, so that way it blocks all of the light and this mimics the leaves of trees. So when I put the tracker back on there, we now have this being in the right position and just rotating and doing its thing over time as the shadows needed and as the other shadows are needed. That's put out as a USD as well, which all combined give me this setup right here. So this is how I can get all of the simulation from just that one basic head track coming all the way back from up here. So I'm just using the GeoTracker's export for transform. I didn't link anything, but I just exported the transform out, and that's where all of the transform tracking comes into play. So the GT tracked transform, if I was actually to do a Control F and type in GT, we'll see all of the transforms. So the initial transform that has the main track, and then all of the copies that I have that are linked. These are all straight from this one by doing right-click action, create reference copy. And that way, if this changes, the other ones change as well. So that's the build overall. And then what I have in here for a render, turn on the camera. I think a good frame around here is around 334 if I remember correctly. Just turn that on. And I can zoom this in just so we can see that. So my scarf has noise material on there to kind of give it some roughness, as well as the pattern and the color. That's all based off of the UV, so it stays put. The hair, I just ended up going for a more natural, if that makes any sense whatsoever, because this is a very unnatural mask, but it's more kind of brownish kind of hair. And I gave the helmet here, this mask, a little more of a pseudo plasticky kind of feel. So this is what tracks onto the skier as he goes down. Every so often, as I'm scrubbing through here, the hair tends to lose its actual shader. It's a weird little Solaris bug. If you turn off and turn back on, usually it'll fix itself. Yep. So this is how we got the skier